Oh, there you go. Excellent connection. Perfect. I love OBS. It is. It's amazing what you can do with it. And you hook that with an ATEM, and it's just a, yeah, you do. You do. And it just, and you can get an ATEM for so, I mean, yeah, just the basic ATEM. Mm-hmm. Yep. Yep. I have one of those at home. I love it. Okay, we ready? Okay, let me know when I'm live. Okay. Welcome to Building Culture of Trust and Information Security. My name is Jeremy Cox. It's a pleasure to be with you today. I am the Director of Technology for Washington County School District. I know many of you, although right now I can't see any of you. It's just blinding lights. So if somebody raises their hand, they may have to yell at me as well. But we're going to talk a little bit about building trust in information security, which is one of the things that I think oftentimes many of our organizations are challenged with, is how do we get initiatives in information security to actually pass, right? To move forward. How do we move the needle? Because so often we take and we push out an initiative to change something and it fails due to users or user rejection or administrative rejection or something of that nature, right? So we're going to talk about what causes this great divide between information security and in IT in general and how we can resolve it. So there are two significant issues. One is executive leadership, a divide between executive leadership and information security. Your second issue we'll talk about in a minute, but this is a real critical one because if you don't have buy-in right at the very beginning with any project that you're trying to accomplish with your executive leadership, your C-level employees, then it's doomed to fail. So what happens? Okay? And I've been in these meetings many times where you go, okay, why is it that for some reason, we tell them, hey, we need to increase security in this fashion, and they come back and say, no, that's too much, we can't do that. Where are they coming from, okay? Well, what you'll find is that many of your C-level perspectives they have the exact same goals as you do, but they have different concerns, okay? So maybe you're suggesting something that they're concerned is going to decrease employee productivity or cause issues with employees just doing their basic jobs. There's also often a lack of understanding and communication. We're dealing with highly technical things and trying to explain that to them, and they're looking at us and glazing over and going, what is it that you're talking about? It doesn't make always a lot of sense to them. There's also the cost versus the investment, right? What are we looking at as far as the cost to make these changes? How much money is that going to cost us? And what kind of difference is that really going to make? Okay. Sometimes our business goals are not aligned on the same level. Sometimes we're very much looking at, we want the ultra secure, and they're looking at it like, well, this is really, we don't need as secure as you think. And so the aligning of those goals can be different. And then this is oftentimes one of those things, the risk tolerances are different. Okay, so they may look at it and say, you know what, that's acceptable risk. And we may look at it and say, not a chance, right? We want that secure system. So how do we get ourselves on the same page? Okay, how do we bring ourselves on the same page? And that's what we're going to talk about a lot. But what this does is a lack of understanding and communication leads to a loss of trust, okay? And then that leads to frustration. And then this is the worst case scenario, right? But it happens, is the security team is seen as a problem. Now, that's the last thing you want in your organization. You don't want to be seen as the team that just says, well, we just have to make it better and bigger and bigger and bigger and bigger. They need to understand why. And if they don't understand the why and they're not aligned with it, then they start to see you as a problem. And then what happens is they stop listening. Okay? So it's really important that you never get to that bottom level issue. All right. Divide number 2 is the employees and information security. Okay? So this is a very common one. You can probably paint the next slides yourself here. But what we're going to talk about is some statistics. So 60% of employees reported frustration when with IT's perceived inflexibility. Okay? 43% of users feel that IT security measures hinder daily tasks. 56% feel security policies negatively impact productivity. And 30% reported a productivity dip after major IT changes. Now, you probably all heard this, right? You could probably had guessed what those numbers look like yourself, because we see this all the time. Every time we make a change, we see, okay, people have to adjust, and that can be challenging. So when they're constantly adjusting, which they have to because technology constantly changes, this is the type of things that we get out of it. So how do we deal with this? But let's more of this. More than 80% of companies engage in some form of employee monitoring, okay? And I'm not going to ask by a raise of hands, but think about how much employee monitoring is going on, especially with remote work. 30% of employees feel uncomfortable with the level of monitoring in their organization. 59% of remote employees were concerned that monitoring software would allow their employers to spy on them without their consent. And employees who are aware of monitoring practices reported feeling less trusted by their employers. Okay, so can you see the kind of the picture that we're painting here? Employees often perceive IT language as condescending and overly complex when explanations use too much jargon, assuming a high level of technical knowledge. 35% of employees felt that IT staff communicated in a way that was condescending or dismissive. Okay? So we've all seen this, right? We've all seen users that come to us and they're paranoid, they're scared, they are fearful, they think that Big Brother is watching them. You've seen all of this type of stuff. And these types of things can negatively impact our ability to make significant change. But what I love is, look at that last statistic. 70% of end users felt more satisfied when the IT professional took time to explain the issue in simple terms. So how do we get from the users are frustrated, they don't get it, they don't know how to move forward, to the users are satisfied? And even if they have to make just a little bit of changes in their daily routine or learn something new, how do we get to them to that point? So this leads to All the other stuff, a lack of understanding communication leads again to loss of trust, which leads to fear, and then security is seen as a barrier rather than a benefit. Okay? We don't want to get there either. So how do we heal the divide? Well, I think the easiest way to describe how we heal the divide in security and these two other groups is we remember that we're a team. We work together. Sometimes we sit in our offices and we think, they're just being, it's an ID10T problem, right? I mean, it's a PCAP, it's a chair to keyboard error, it's the user's fault. And we say that all the time, and you know what? And I get it. And between us, it's like, we got to blow off some steam. This is driving me crazy. I got this user over at this building who just can't get it. And in the middle of the night, they did all of these things and messed up everything, right? You've all been there. We've all had those frustrations. The challenge that we have is when those frustrations are now perceivable by them, it starts to change the way that they look at us, right? Instead of looking at us as a team together, now we're seen as, it's those IT guys, right? They walked in the door, okay, what's wrong now, right? Have you ever had that happen, walk into the door of the building and somebody comes up to you, okay, what's wrong? Like, it's happened to me at least, I cannot tell you how many times it's happened. It's like, do I ever just come to a place just to say hi? And I do, but right? When I started to hear that, I went, okay, yeah, got to change that perception. Because the last thing we want is to be the harbingers of doom, right? We don't want to outstrip the HR directors out there. We don't want to be those people, okay? All right, so here we go. And my father was an HR director, so I can use those jokes. Anyway, so the way we change this is we change the way we communicate, right? The very first thing, we seek first to understand. We have to understand their point of view. Oftentimes, it kind of like we look in our wheelhouse and we say, okay, this is the way it works from a technical aspect, but we actually sat with an employee to actually see how their workflow works, okay? If we could understand how their workflow works and what they're doing on a day-to-day basis, we may understand how to better serve them, okay? Number two, this is often challenging, right? We simplify and use non-technical language. Okay? How easy is it to describe something that's highly technical in a very non-technical way, right? That's not a simple ask. You know what's really great at coming up with those types of things? ChatGPT. So there are tools out there that can help you as you're trying to figure out, how do I describe this very highly technical thing to a non-technical group? And I love this part, right? We use stories and analogies. We just heard a lot about that, right? Because stories and analogies, those types of things can bring an emotional connection, all right? And it can communicate a point in a way that we may not be able to. If we sit down and we talk about why when this port is open on the internet, it is a problem, they're going to look at us and like, what port are you talking about? Well, they're going to look at us and go, I don't even know. You just said, German or Greek or whatever it was, and they glaze over and we lose them, right? So we can use stories and analogies to help explain concepts. We want to foster cross-departmental collaboration on security initiatives. So when we go through and we say, okay, let's make major changes to the business system, okay, because there's a very huge risk associated with the way they're doing it, have we gone and we talked to them about that risk? Have we explained what we're seeing so that they can come to that same conclusion themselves and then help them be part of the solution so that they own it? You know how much more people will take and actually support a solution if they truly own it themselves, that they were part of the development of that solution? They may not understand all of that happens on the back end. Well, they won't, right? There's no way that they will understand it like you do. But they can be part of the development of that solution in a very rudimentary way, and they'll own it, okay? We have to be transparent. Sometimes one of the things that we often do in IT is we just say, that won't work. Can't do that. Not going to do it, won't do it. And that could be either because there's a technical limitation, or that could be, hey, you know what, I just don't feel good about that. Tell them why. Even if they don't fully understand the why, if you try to explain the why, they will start to understand why it is that you can't make those changes that they want, and then come to resolution. You may have to say, well, we may be able to do this, but we can't do that, and this is why we can't do that. Okay? Or if you don't have the money to do it, well, I could do that if I had these resources. But anytime you try to direct a problem to a positive rather than a negative and a complete shutdown, it changes the whole stance of the way that you communicate with that team, and it makes them feel like that they're part of the discussion. Okay? Empathy and support. These are critical. So if we can show empathy for understanding where they're coming from and help them explain where we're coming from, okay, which is part of that seek first to understand before being understood, then we can change the way they view us. They can view us as, yeah, we understand that this is hard for you. We get it. These are all the things that we can do to help make that better, including we'll be happy to come do training. We'll happy to, make some tweaks there to make that better. But in the end, we're trying to make this goal. So let's work out a way together that we can make this goal. Okay? We need to be approachable, have user-friendly documentation. And lastly, we need to find balance. Okay, and adjust solutions to meet both the C-level and the employee needs and the security goals. So there's lots of different ways to cut this up, right? We don't always have to do, in order to meet our security goals, we don't always have to do it one way. Sometimes there's different branches that we can take and different ways that we can allow the C-level goals to be met and the user-level goals to be met, or compromise to find common goals that work so that we don't give up on security and we don't get shut down on security, but we find something to move the needle. And it may only be a little bit at a time, but we're going to move the needle a little farther, okay? Because oftentimes what happens is we say, well, we want it all the way up here, but really and truly they're like, well, we're down here, and to go from here to here sometimes can be really jarring and really challenging. So if we can kind of meet in the middle somewhere and then eventually start to move it farther and farther and farther, you'll get a lot more support versus going 100%. Okay? All right, so let me tell you a story about Washington County School District. We spent nearly a decade trying to change the image that we had with our users so that individuals would start to trust us and believe that we had their best interest in hand, which we do. We want to protect them, okay? So over the past decade, we spent a lot of time sending out emails. And if they want to read them, they want to read them. If they don't, they don't. But what we found is the more that we sent out emails that were applicable to what they were dealing with day to day, and the challenges that they were facing, the more they would read them. In fact, I'd get emails back saying, hey, do you mind if I share this with my family? This is really good information. Okay? We'd have those types of things all the time. And so we would send out these regular emails of things that were currently going on, the threats that they were facing, to help them be able to mitigate those threats. And they were applicable to them. And we used language in those that they understood and they could relate to and they could see a benefit from. And what this started to do is it started to create that bond of trust, right? They went, okay, like they're giving us good information and good data that is actually useful in real life. And it took some time to get a lot of people to start reading these, right? It's not like we don't get 50,000 emails in our inbox every day, right? So what differentiates between an email that you want to read and the emails you just hit archive and delete, okay? You have to have value in it, right? And that may take a long time to gain because it's kind of word of mouth. It's like, have I seen value in that email before? Maybe I'd actually want to skim through this. And the other thing is, well, how long is it? And right, there's all sorts of things you can do to keep that simple, good information that they're going to use and it's going to be helpful to them, okay? So rather than focus on what they should not do, we focused on explaining why we would not personally do what we didn't want them to do. Does that make sense? So we just said, instead of saying, don't do this, we said, well, if you were to get this and you did this, this is what would happen. Which gave them the same conclusion of, don't do this, right? So we spun it just a little bit different so that we said, hey, here's the context of why this is important. And it allowed them to make that conclusion in their head, which also means that it's going to stick better, okay? And we use simple examples to explain complex issues and put it in terms that they could relate to. Let me give you an example of an email that we sent. So not too long ago, this was actually later on in this process, we sent an email that talked about, we realized that we had a huge problem with individuals using their organizational email for personal purposes, okay? So they were signing up for every type of personal account, all their, Apple accounts were tied to it. I mean, it was like rampant, right? And every time I walk in and like, oh no, you pull up somebody's computer and work on it and like everything's attached to their WASH K-12 account. And we'd sit there and we go, this is not good, right? We'd have employees leave and then they call us up and like, hey, can you reactivate that email address? I just found out that this is all attached to that. Okay? So you're shaking your heads and laughing because you've all dealt with this, right? Now, in a government organization, who can tell, can you all raise, anybody who thinks that using their business or government email account for personal stuff is a good idea, raise your hand. Okay? Because all of us know why we would never do that, right? We all get it. So what we did is we sent out an email and we told them everything. We were totally transparent. We told them that, listen, all of your government emails are subject to GRAMA. They could be GRAMA'd at any time, which means that you could send out a Government Records Management Act request, and we may have to release those emails. And even if they didn't fall under the GRAMA purview, somebody's going to actually have to go through your email to find out if it is. So do you really want someone going through your personal email? I mean, we laid it all out, and we explained every reason why we would never do that. And then we said, okay, now you have the information. This is, we don't recommend that you do this. But we didn't say, don't do it. We just gave them all the reasons not to do it. Because at the end, they read the email, they went, I'm never doing this again. In fact, we got more calls about, how do I move all of this stuff off of here? Because I don't want to do this. And so it changed the entire narrative of how it worked, simply by changing the way we approached it. Okay? So, afterwards, what happened? So we built this trust with our employees, and we used the exact same techniques to explain the new security initiatives. The latest security initiative that we went through, we used these exact same techniques. We came through, we explained why it was important, we helped them to come to that exact same conclusion themselves. And then the results were fantastic. We used test groups to determine impact. We said, okay, we're going to turn it on for this school. And you guys let us know how it works and what you need and how we can support it. And so, and we chose that school wisely. Like we're going to choose a school that is representative of of most of the schools. It has the majority of the users, that we've got every type of different user that might be there. And then we ran through that process, and then we found solutions. Every time They ran into a problem. We said, okay, what if we did this? Would this help? And we worked with them. Okay. We enlisted the buy-in from our executive staff. We discussed all of the available options with them and then allowed them to become part of the solution. Okay. We talked to them. We said, okay, we can do this. These are the options we have. This is the things that we can do. And these are the things that, that we're required to do. And then we allowed them, by using stories and discussions and analogies, to come to the exact same conclusion that we had already really come to. Okay? So they became part of the solution. So it was very successful. So the afterword is this: good and empathetic communication is the key to success. If you want to be successful, figure out, how do you communicate an initiative? How do we get buy-in? How do we have users that are excited about a change because it's going to help them rather than hinder them? And that is good and empathetic communication. So again, we change the way we communicate. Seek first to be understood. We simplify. We use stories and analogies. We foster cross-departmental collaboration. We be transparent. We use empathy and support. We find balance and adjust. Because good empathetic communication changes culture. Because we truly are on the same team. Most of your organizations, you will find that users and employees and C-level have very common goals, but the way they see the path to get to that goal is very different, because everybody understands things just a little bit differently, okay? And everyone has their unique abilities and skills and knowledge. We see things from a very technical standpoint, but every person needs to feel like they are part of the team. And you notice I bolded the feel, because they really need to feel like they are part of the team. It is all perception. Every person should feel valued, because good teams recognize each person's value contribution to the team, and they work. And they work fantastically. Okay? But changing culture takes time. This is not something that you will be able to do tomorrow. This is not something you will be able to do in the next 6 months. This is something that will take years to develop. If you feel like you're in an organization where the culture is such that the trust is not there between your employees and your IT department, changing that perception will take time. Okay? There is you know what? I do have audio. Can you give me audio? Okay. There's a great YouTube video here that we're going to show you that emphasizes this point clearly. And of course, the audio is coming through my laptop rather than to you.
Men of Rathor, my brothers, this day you fought with honor. This day you vanquished those that mean to smite us. The Dark Lord forged his enemies to wreak their terror, but we persevered and slayed them forthwith. In the years to come, they will sing our victory song, as we sung for our forefathers.
Sorry. Sorry, guy. Just one thing I thought I might bring up.
Whatever is it, brother of the watch, fellow kinsman?
Yeah, this.
Honored knight of the Third Men.
This is what I want to talk about. We are using way too many words, guys.
How doth thou mean, proud warrior of the North? Brave son of the arm...
There. That's what we could really speed things up around here if we just cut down on the wordage.
How so, brother of the cloth? Defender of the North.
Well, like in battle today, when you yelled, I'm paraphrasing, but noble horde, raise thy shields, from yonder field of battle approaches, is it thy enemies' arrows?
Yeah.
Yeah, next time, just yell duck. I reckon. You know, I mean, a lot of us died before you finish talking.
So, not speak in such an elongated way for the sake of time.
Exactly. Actually, and just while we're on the topic, we were just talking about this, weren't we? The tales that we tell, the one about the ring and the short, hairy foot people, maybe that could be just one story, you know, instead of 6 3-hour unnecessarily long stories.
Some merit you may have in your words, my brother. I see how my verbose retelling may elongate the...
I don't think you do.
No?
Yeah, even this, the victory speech you're making, I don't know. I just think maybe just say we won or something. You know, you guys, yeah?
Yeah. Your words have resonated deep in my mind, my brother.
Again, I don't think they have, because he's still doing it.
We won! Yeah!
All right. We won. Thank you very much. Have a wonderful SAINTCON. It's just a YouTube short. Hey, thank you. Here, can I have you take off the rest of that?
I saw earlier. Perfect, thank you. So I'm sorry, I actually pinged you on Discord while you're talking. I didn't realize it. Oh, okay. Do you have one more radio that you can have for the rest of the conference?
Yeah, absolutely.
Okay. Do you mind if I follow?
Where do you want to meet me?
I could actually just follow you. Okay.
Let's ask you a couple questions.
What's that? Oh, no. I'm presenter. Dave. Dave.
Oh,
Do you want
Jeremy.
handles or anything down the street?
Let's put this on in. Let's get entangled here. There we go. Okay.
So I got a big old head.
Is that on there? Okay.
Thanks, man.
There we go. Okay, I think we got it now.
Yeah, we just gotta get this guy down here, maybe.
Yeah.
Oh, sorry, I don't want to mess you up.
Just for comfort. Alright, and then if you want to just put this in your pocket, it's already turned on. It's got a clip on the back. You can hang it on
Okay.
your pocket.
Do you want to make your socials now?
I really don't have any.
Or like email so you get some videos?
Oh, are they gonna be posted like on YouTube or something? Or?
But if you want the raw ones,
Okay.
LinkedIn or anything.
Yeah, do that.
This thing.
Struggling, huh?
If you want to write down.
Just like an email or something? Or?
We have a different one, right? It just has one ear. We just need one ear. This doesn't seem to go quite wide enough. Yeah, that's his. This one doesn't quite go wide enough to get over both of his ears.
You can run if you want to. Do you need a monitor? Yeah, you can put this on your neck if you don't want to hear yourself.
Yeah.
Oh, no, I don't.
Oh, this
Oh,
actually doesn't have that, but yeah. Try
Just do it around the neck.
putting it around the neck and see if that.
I mean, as long as they can hear, it's fine with me.
Yeah, and then just like point it upwards, and yeah, you should be good to go. We can
Okay.
do a test if you want. It'll just
Go ahead and get your laptop plugged in and we'll...
No, they just throw them away. Perfect. It's in there. Thank you.
Oh, you're good.
Sorry to kick you in the shins there.
No, it's laptop. So it's all good.
That might be worse.
Nah, we're good. All right, then. I don't think so.
Okay, sweet.
We're good to go? Okay. All right, welcome everyone. Thanks for coming to my talk today. My name is Dave Bogle. I'm currently a security researcher at Red Canary. And today, my goal with this talk was to be able to tell a story, right? Probably not as cool as Jack Resider's story this morning, but I do hope to share a story that will be helpful for all of you, especially those who are either in cloud security right now, who are maybe thinking about getting into cloud security, or who are just still trying to figure out their security journey in general and don't really know what they want to do yet. So what I hope to talk about today is my experience going from an endpoint researcher in security to cloud, which for me was a very big change. And there was a lot of lessons learned that I took from that I hope I can share with some of you who are starting your journey in the cloud. So my role at Red Canary is I'm our Linux threat researcher. I also spend a lot of time looking into Kubernetes and GCP and Google Workspace and other cloud services. I love riding bikes, road bike, mountain bike, biking with my kids. And of course, I've got 3 kids, so I had to put a Bluey reference up there because that's like the greatest show ever for both adults and kids. Very entertaining. So next talk, I'm going to talk about why there's been so much interest in the cloud, right? Why are we talking about it? It's been around for a while now, but probably only within the last decade or so has it really started to see a lot of growth, right? That businesses have been moving very rapidly into the cloud, and I want to talk about why that is, right? And what it offers to businesses. And then I also want to talk about, okay, if you want to be a security researcher and do security in the cloud, what do you need to know? And for those who maybe have already gotten their feet wet and done a little cloud research already, I'm hoping to provide maybe a few examples of some things that will help continue that journey of research, and were some things that I learned as I very quickly had to learn all the deep intricacies of how the cloud worked. And then finally, I want to talk about sort of the trajectory beyond, right? So once you're already in the cloud, you're doing great, you're learning awesome stuff, you're secure in all the things. How do you continue to grow in that research, right? And how do you take it even further to continue to protect your organizations or further whatever research you find interesting? So to start off, why are we talking about the cloud? Well, like I said before, I come from a background of very low-level security research, right? So I love bits and bytes and assembly and C code. That's my favorite language to program in. So why am I talking about cloud security? Well, I worked at a company that is trying to get into cloud research, right? And offer products that protect customers' cloud environments. And so being one of the threat researchers, they're like, hey, you should go learn cloud and then help us build a product around that. And I said, sure, of course, easy peasy, right? It wasn't that easy, right? It was a pretty painful experience for a while, and that's hopefully a lot of what I'll be able to share with you is what I learned and how I overcame some of those struggles. But like it or not, a lot of businesses are moving to the cloud, right? Some are entirely cloud native, right, where the core of their business operations exist in some cloud provider, and others are just sort of toying with the idea, right, where maybe they have some on-prem stuff still, but they have some of their services offered in the cloud. But either way, it seems like a large majority of companies are starting to push resources and business operations into the cloud. And why do they do that? There's a lot of reasons. Some would be ease of deployment, right? So you can reliably and very easily deploy very complex infrastructure into the cloud. Rapid prototyping. So if they're just trying to test out a new product, maybe they want to build it in the cloud first, see how it works, and then consider whether or not they want to host it in the cloud and maybe on-prem. It allows you to very easily deploy things globally. So if you have a global customer base, right, the cloud can help with a lot of aspects of dealing with that. And then finally, one thing that I advocate for is I think, and this is maybe a hot take, but I think that cloud platforms inherently are more securable than on-prem stuff, right? And I get that a lot of people may have different opinions about that. We can talk offline if you want to get into the details. Totally fine with me. But I think there's a lot of security benefits to hosting services in the cloud, right? But that's a talk for another day, maybe. So cloud's the future, right? Want to do all things cloud? Sort of. So I feel like I had to put this in here because as I've been researching the cloud over the last few years, I've noticed that not all companies agree with that. So I just want to put it out there that cloud doesn't work for every business, right? Some businesses find it easier or more cost-effective to host things themselves. That said, right, despite all these headlines talking about all these companies leaving the cloud, we've seen cloud sales and profits rise phenomenally over the last decade, and they're continuing to rise, which in my mind is pointing to the fact that there are still lots of people, and probably even a majority of businesses and people moving their stuff into the cloud and paying money to cloud providers to host services. All right, so let's talk about getting into the cloud. So I covered a couple of these already. I'm not going to talk about each one, but these are a few of probably the biggest reasons cited by companies as to why they want to move to the cloud, right? And every business may have different reasons for doing so. I think this touches on a lot of them, but I'm not going to dive into each one of those, but there's that for reference. So now I want to talk about how the cloud works at kind of a high level, right? And the reason I want to do this is because I want to sort of paint the landscape as to different areas of cloud research that you might get into. And when we think about cloud research, you have to think about all of the different attack vectors that an adversary might have on a cloud environment. And I think it begins with a computer, right? So it could be your personal laptop if you're a cloud developer, or maybe you're a security engineer, right? You have your own computer, it has credentials, it has access to that cloud environment, and that computer has to make requests to the cloud. Those requests go across the internet, right? And we'll just pretend it's the magical internet that just somehow gets your packets to the cloud. Your packets then reach the cloud provider, whoever that might be, AWS, Azure, GCP. And then once it gets there, then it's routed to whatever specific resource you're interacting with in the cloud, right? So maybe it's your SQL database, your cloud storage, your cloud functions, Lambda, whatever it might be. So let's look at each one of those pieces one by one and look at how some of that access occurs, right, in that whole pipeline from the beginning. So starting with your computer, right, there's a lot of different ways that you can initiate that request. Some of the most common ones is maybe you do it through your browser, right? You log in to the cloud provider's console, you click a bunch of buttons, you provision VMs, Kubernetes clusters, storage buckets, whatever it might be, and you're doing all that through a browser. Another way you could do it, and my preferred way, is you can do it through a CLI tool, right? So AWS, G-Cloud, AZ, you can more programmatically interact with it through that way. You could also use the myriad of third-party tools that exist that are leveraging SDKs the cloud providers have built. So if you want to use your favorite third-party tool, they might be pulling in some software libraries to help them interact with the cloud. So maybe some less common ways, curl. It's a great way to do it. I use that more often than I would have thought I would have. But sometimes you just want to hit it with like a straight GET or POST request or whatever, and you need to be able to customize that command a bit more. Or, at the end of the day, interacting with those cloud providers are just API calls. So you can use whatever programming language you like and just send a request via an API call, and you can interact with that cloud provider. So there's lots of different ways you can do that. The way you actually get access, though, is you're going to have some kind of credential on your machine that's going to be used to authenticate and authorize you to access those resources, right? And we'll talk a bit more about that in a minute. All right, so where do those packets go once you send that request? Well, at a high level, when you make an API request, and I have an example of a command down there using G-Cloud, if you were to, let's say, provision a new VM instance, what the gcloud tool is going to do is basically just format an HTTP request, right? In this case, it's probably going to be a post, and you're going to post to some URL endpoint that's hosted by the cloud provider. And so that packet, just like any other HTTP request, is going to go through the internet. It's going to hit one of the edge routers for whatever cloud provider, and then that will analyze it and route it to whatever the appropriate service is that you're trying to interact with, right? In this case, virtual compute. So let's dive a bit deeper into the part of once that packet hits the cloud provider, what happens, right? Well, you've got an authentication phase, right? And that's the act of validating that the user sending that packet is who they say they are. Then you have an authorization phase, which is making sure that that user is allowed to do what they want to do. Then there's a validation step, right, where you actually have to make sure that request is valid. And then finally, you have the execution of that request, which could include rejecting it if it's decided that that shouldn't be allowed, or accepting it and then provisioning the resource or changing it or whatever that request happens to do. So if we were to break this down, our packet makes it into the cloud provider's environment, and we hit the authorization phase. And so at this point, this is where we're looking into technologies like OAuth 2.0, bearer tokens, JOTs, JWTs, and kind of all of the things related to that, right? And that's where it's just trying to determine, are you who you say you are? Can I verify your identity, right, as whatever user you claim to be? Assuming that you pass that check, you then go to the authorization phase. And at that point, it then looks at the IAM policies, right, or the roles, or the OAuth scopes that you might have applied to your access token. And they will make a decision, the cloud provider, as to whether or not you're allowed to interact with that resource. So they know who you are, and they say, okay, well, you know, Dave Bogle has verified his identity. Now, is he allowed to spin up a new virtual machine, or write something to a storage bucket, or interact with a Kubernetes cluster, right? And that's where those checks will happen. And then finally, you have a validation step, right? And this is where we're looking at policy. So you might have organizational policies that, even though a user is who they say, the roles that they need to interact with the resource, there may be overriding policies that then block that request, potentially. And so there's policy checks that happen, format checks, resource validation, so making sure the resources they want to interact with actually exist. And then finally, after all that work, your request can make it to whatever service you were trying to interact with. So there's a lot of steps that go in there, and there's a lot of cool research that can be done during any one of those phases, right? So that's just yet another avenue of cloud research that you could potentially get into, where each one of those technologies, right, OAuth 2, IAM, OAuth scopes, organizational policies, all those things can be deep and enriching fields of research. So how do we become fluent in the cloud? Well, I think the very first thing, and this is probably the hardest thing for me, is it's like learning another language, right? When I first got in the cloud, people were just throwing all these words around that I didn't understand, right? Principles, permissions, roles, scopes, RBAC, right? All these things that I was not familiar with. And so it was very hard to keep up with some of the stuff I was trying to read and understand if I didn't have a good foundational understanding of the vocabulary. So one of the first things I did was I just went and said, okay, let me find sort of the cloud buzzwords, right, that pertain to cloud security, and I'm just gonna dive into each one of those and make sure that I understand it really well. And I even took the time to understand it across the different cloud providers, because each cloud provider will sort of have their own dialect and their own meaning attached to some of these words. And so I actually made like some notes where I had like AWS, Azure, GCP, and I was like, in AWS, this thing is called that, but in Azure, they call it this, and in GCP, they call it something else, but it's all basically the same technology, right? And that was helpful for me to build that mapping to kind of bridge those concepts as I was bouncing around cloud providers. Can I share that? Maybe, actually. We can talk more about that later. But yeah, so they all have a common language that they speak, but then each of them have their own dialect, right? And that's one of the hard things when you're trying to move between cloud providers. And the tricky thing is in the past few years, companies have really been liking the idea of multi-cloud deployments, which then becomes really hard for us as security researchers, because you're like, not only do I need to understand AWS, which has over 200 services, each of which can be very complex, and have a huge threat landscape, but now you want me to do that in Azure, and then you want me to do it in how they interact with each other and how they share identities between each other and all that, and it just gets really messy really quick, right? So trying to build that foundation and understanding of the different services and the different vocabulary can be helpful for bridging those concepts and quickly pivoting between cloud environments. So it definitely takes some time to understand the language of each cloud provider and some of their unique words. So I listed out a few here that I remember spending some time really digging into. Again, I'm not going to go through each one of them, but if there's some of these that you see that you're like, oh, I don't even know what that means, go take some time, research it. Tons of great blog posts out there, lots of good materials for every single one of these, right? But remember, the caveat is it may mean one thing in AWS, it might mean a different thing in GCP. So you got to make sure that you're understanding that in the right frame of mind. All right, that's there as a reference. So how do we get into cloud security fast, right? Because nobody wants to spend a long time, learning each thing. We've got lots of things to do, meetings to go to, cool tools to build. So here's a few of the tips that I felt helped me get up and running very quickly, right? And this came from my background as an endpoint researcher, where I often was tasked with, hey, you need to dive into this concept, and I had to learn it really fast and in depth as quickly as I could. So first, don't be afraid to just get your hands dirty, right? And I think back to Dave Kennedy's keynote yesterday, where he said, just do it, right? Just get into a cloud environment, start provisioning stuff, start playing around, and just get your hands dirty, right? Get in the cloud, and you'll learn so fast by doing that. But from what I've seen is I've helped other people in my company also get into cloud security. People seem to be very hesitant to just get into a cloud environment and spin something up, because they're like, what if I break something? What if I end up costing our company $10,000 because I spun up some super fancy VM with a huge GPU on it and it's just costing a lot of money? I mean, that's probably not gonna happen, right? More often than not, you'll get in there, you'll spin up some resources, and you'll learn a ton by trying stuff that you thought was gonna work, and then it totally doesn't work. It happened to me all the time, where I was like, you know what, I know all about cloud functions in GCP, like I'm an expert. And then I'm like, okay, I'm gonna spin one up and I'm gonna tie it to like a storage bucket. I want something to read from that storage bucket and do a pub sub event for when something's written. When I actually got in there to try and provision all that, I realized I had no idea what I was doing. So like conceptually, I understood it all, but practically I couldn't do it. And so that was an eye-opener for me that like, I just gotta get in there, and when I'm learning about these things, I need to actually be using the CLI or using the console to be spinning up these resources and playing around with them. And you'll learn so much just by doing that. Now that said, you do have to read the manuals. I'm sorry, I apologize. There's no way around it though. Generally though, the documentation is actually pretty good for a lot of these cloud providers, which I don't say that lightly, because I've read a lot of great documentation. I've read lots more terrible documentation. And my experience has been it's actually pretty good. So definitely don't be afraid to get in there and to understand what they're offering in terms of insights. They oftentimes will have lots of practical guides as like, hey, if you want to build this thing, here's a quick tutorial on how to do it. It'll walk you through the steps, talk about some of the configuration options, and that can be really helpful. Specifically focus on the security side of things, study what's already available. So there are lots of good red team tools that you can look into if you want to understand sort of the offensive cloud security stuff. There's tons of great talks given at many conferences about lots of different cloud topics. So search around YouTube, Google, find some talks that you really like, and dig into specific subjects based on that, because there's a lot of good content out there. And then another thing that I like to do and I like to remember as I'm getting into cloud security and researching something is make sure you stand back and look at the big picture. And what I mean by that is the cloud is just someone else's computer, right? So don't forget that. When you're making these API requests, right, even though that's maybe your only way to interact with some service, there's just an HTTP server on the other end listening to these requests, processing them, and then probably spinning up some container or something like that to then provision some resource or change it, right? But keeping that big picture in mind, I think helps frame how you want to find new areas to investigate. And some of the coolest research I've seen has been when people understand that like behind these fancy UIs in the browser and behind these CLI tools that do HTTP requests are just virtual machines that are running by this cloud provider. And there's a lot of interesting stuff that you can dig into that way. but it also just helps frame how you're picturing the threat landscape. And then finally, if you are interested in it, certification and training programs. There's like a million of them out there, so I'm not going to recommend any particular one, but there's lots of good stuff out there if that's a route you want to go down that are great programs and will teach you a lot of the basics. Now, a couple pitfalls to be aware of. Security research in the cloud is not security research on endpoint. That was one of the hardest lessons for me to learn, is I wanted to treat it like I was doing endpoint research, like I was looking into an operating system or something, and I couldn't do that. Like, it just wasn't the same. As much as I wanted it to be, and I was trying to like bring parallels between the two, it's just not the same. So go into it with an open mindset if you're coming from a background in endpoint research, right? It's going to be different. That's okay. It's interesting in its own ways, right? And there's new problems to solve in cloud that just don't exist on endpoint. In the cloud, any single audit event that you might see or event that occurs typically is not going to be enough to do something actionable from like a detection perspective, right? So if you want to tell a story about something that happened, right? If there was some compromise in a cloud environment, and you want to try and paint the picture of, well, here's how they got it, and here's what they did, and here's all the things, right? That's going to be combining a lot of different information into one. And one of the things that's really hard in cloud research is figuring out what are the most important pieces of information for being able to tell a story about something that occurred in a cloud environment. And then finally, the last thing, and probably the most frustrating as a cloud researcher, is it just changes all the time. So one thing that I've started to integrate into some of my research is just watching those changes over time. So when I started looking into GCP, for example, there were, I think, about 8,000 or so unique permissions, right? The last time I checked, and I have to go double check this, my data could be old, I think there was 11,000 permissions, right? And so things are, and that was, not that long ago, right? So it's significantly changed over time. And some of the permissions that existed before have switched and changed as time has gone on. So that's just one example, right, of just how the cloud's constantly evolving. And you don't necessarily have a nice like release of, oh, hey, there's this new version that got released in the cloud, and now we know these things changed at that version mark. They just change, right? Things just change all the time. So that can be really tricky from a research perspective, because you can't always assume that something you researched a year ago is still going to behave the same way that it does now, right? So a couple bits of advice. Learn how to tell a story. So with so many different technologies that go into the cloud and cloud security, you really have to bring in a lot of different information to tell that whole story, to understand what happened or how something occurred. So learn how to tell that story and learn what pieces of information can help you build that picture in your mind of what occurred in a cloud environment. I think the other big thing is identity is a key part of cloud research, and you can't really do cloud security research without understanding identity to some degree. So you're definitely going to have to tackle that as part of research if you want to get into cloud security. And then finally, the last thing that I think is super helpful is understand how people use the cloud, because it's always different, right? So if you're a researcher and you're just trying to secure your own company's cloud assets, then understand how your engineers and how your customers and how your employees use those cloud assets. And that will help you focus your research on the things that will be most impactful. If you have the opportunity to secure other customers' environments, work with them to understand what are the threats they're worried about, what are the problems they're facing, what do their environments look like, and again, that will help scope and focus your research. Because with any major cloud provider, you've got 200 plus services, you just don't have that much time to dig deeply into each thing, right? So make sure you understand how people are using it. Last but not least, don't be afraid to experiment. I said that before, I'm just gonna say it again, right? If you're trying to get into cloud security, just do it, right? Every big cloud provider offers a free account. You can get some free credits. You can just get on there and start messing with stuff. Like, please, just do it. You will learn so much, and you may even find that, like, it's not your thing, and that's okay too. And security is a team sport, right? Work with, we're showing that here at this conference, right? Is we're all working together to understand security better. And so, yeah, I love that there's so many of you who are interested in this. And definitely don't be afraid to reach out, talk with others, network, work with people in your company to just build a better security product. And last but not least, is learn to love to learn, right? And that's something that I have learned as I've done research for the last 10 years and different things, is you just have to learn to love the process of learning. And it's hard, and it's painful, and it sucks sometimes, right? And I didn't like cloud at first. I'll be honest, I'll say it, I'll admit it. And it was really hard for me to make that switch. But as I got into it, and as I just dug deep, I started finding things that I did like, and some stuff that I found really interesting. And then I began to love the process of learning new things about the cloud, and found a lot of new interesting things to look into. So with that, thank you all for coming to my talk. Appreciate it. Thank you.
You guys have any issues putting this on earlier?
Yeah, a little bit. So we eventually just threw it around my neck and were like, good enough, maybe.
All right.
Maybe I just have a funny shaped head.
All right. Sounds good. All right. Thank you.
Yeah.
Are you the next speaker? Okay, perfect.
Okay. Oh, yeah. Nice. Check, check, 1, 2. Testing, 1, 2. Check, check. How's it look? I'm talking about open source vulnerability management. Testing, testing, 1, 2.
Okay, I'll take these off. And then set up the laptop up there.
Awesome. Still some people coming in. Hi to my team. Hi to my wife. My name is Steve Christians. Today I'm going to be talking about open source terrors, or the risks of open source software. This session is aimed at individuals where their company is just starting to look at open source software, and they want to better understand the risks that they need to pay attention to. And while I don't really enjoy modern horror movies, there's something about the macabre that I just find fascinating and kind of fun. And so we're going to lean into that fear for this slideshow. So I hope you're excited. Thank you. So what are we talking about? First, we'll just kind of a brief overview. We'll talk about, I'll go into basics of terminology, dependency management. We'll talk about the types of risks, and then look at strategies and resources for mitigating that risk. And hopefully you'll leave with some basic action items for addressing things. So who's the voice in your head? Like I said, my name's Steve Christians. I've been into security since I was looking through photos from a DEF CON magazine. No. Photos at DEF CON from a GamePro magazine. So that was probably somewhere in the 90s. It's been a while. But I've done pen testing, application security, vuln management. I'm currently the application security architect at Bamboo HR. Just a random thing, my favorite job title that I ever had was pre-college days. I was working at a credit union, and for a while I was their Patriot Officer, which basically meant I managed some software called the Patriot Officer. But it was a great title, and I loved it. My personal life, I like spending time with my family, being outdoors, getting together with friends, and board games. So, foundational stuff. Let's talk about the basics. So first, terms. So open source software is software with source code that anyone can expect, modify, and enhance. It's also referred to as FOSS, free and open source software, or simply OSS. In this sense, it's free as in the freedom to use how you like, or free as in speech. That's different from no-cost software, such as maybe Adobe Reader or Safari browser, and that's free as in beer, if you've heard those, those two terms. And let's see, how prevalent is open source software? If you're here, you probably know that it's extremely prevalent, right? There's this report, the 2024 Open Source Security and Risk Analysis Report. They surveyed over 1,000 code bases, commercial code bases from various industries. And from that, they said, okay, 96% of these code bases contained open source software. And from that, 77% of all the code originated from open source software. So these are commercial repositories. Maybe it's, a company's web app, a hospital's applications that are, running a lot of important information. And 75% of that, 77% of that could be just open source software. So open source is all over the case, all over the place. Even if your company doesn't care or doesn't know about open source, it still has a major impact on your business. So dependencies. Dependency is another term you'll hear all the time if you're talking about open source. Dependencies are libraries or pieces of code that a project uses to implement some necessary or useful functionality, right? When a software component relies on another, it's dependent. And these relationships are often visualized with dependency trees or graphs. You can see them on the slides here. You'll also see them in different package managers, maybe not as pretty. But you have both direct dependencies, so you've got your parent project, then has a child or a direct dependency that it relies on, and then those direct dependencies also bring in dependencies, and those are called indirect or transitive dependencies. And so you see some very basic dependency trees here, and these can get more complex, and they can get really messy. So this is a dependency graph for a recent version of Kubernetes, a pretty widely used open source project. And if you're here and you're already managing open source risks, this might be one of the scariest slides in the presentation. I see a few nods. It's like dealing with this is a pain. It can be a lot of fun. It can mean job security, especially, but it can be just a huge headache. I like this illustration as the dependency graph for your company's monolithic code base, right? If you've got a monolith, if you've dealt with a monolith, look at a dependency graph, and you'll be like, you might cry, you might scream, because it might look like this pile of spaghetti. And then you've got the developers. Oh, dropped out a minute. You've got the developers in the background just making merge requests to it, right? Okay, so still dependencies, open source dependencies, they're part of your development family. And they're in that family even if you're embarrassed by them, if you don't know they exist, if you don't even want to talk to them at family gatherings, they're still part of the development family. And how many dependencies are part of the average project? That kind of depends, right? So I looked at Kubernetes. It has 110 direct dependencies, 99 indirect. And this was version like 1.31.1, a very recent version. Looking at Chromium browser, there was 235 direct dependencies. Axios, a big NPM HTTP library, 3 direct, 5 indirect dependencies. But then over 100,000 NPM packages also depend on Axios. So every single one of those 100,000 packages are pulling in those dependencies that Axios depends on. Same thing for the Python request library, just 4 direct dependencies. This Fabric that I use, that's kind of an AI tool, 17 direct dependencies, 72 indirect dependencies. So if you've got a project, if you've got a project, you're pulling in some open source, you might just have a couple of dependencies. Maybe you got 5, maybe you got 7. But how many dependencies do your dependencies have? There's something to think about. So what if you have microservices or a distributed monolith architecture, right? Some things to think about. How many services are using the same dependency? Maybe you have 500 microservices as part of your ecosystem. Are 10 using the same dependency? Are 200 using the same dependency? And then are they bringing in the same version? Or are they all relying on different versions of that dependency? How many use different dependencies to achieve the same purpose, right? To serve the same function. So once you start to look at this, you might start to feel a little bit nervous. You might start to feel like, hey, this is a complex problem, right? And why do we care about all these dependencies? It's because every single one introduces risks. And risks can be scary, right? They can cause you a lot of problems, and your business especially, right? So let's talk about those risks. So first, vulnerabilities. Vulnerabilities are the worst. When you bring in dependencies, you bring in vulnerabilities. And there's a lot of things about vulnerabilities. I love this quote from the Google security blog. Most vulnerabilities are in your dependencies rather than the code you write or control directly. So even when your code is not changing, there's a constant churn in your vulnerabilities. Some get fixed, others added. So you might have a project that you say, hey, this is pretty stable. There hasn't been any merge requests to it for a year. We're fine. But the dependencies dependencies, maybe there's been 10 vulnerabilities released for the dependencies that project uses. So if those dependencies haven't been updated, you just might be more and more vulnerable as time goes on. Other things, exploits are generally public knowledge, at least for some subset of vulnerabilities, right? The Equifax breach was due to a widely publicized and patched struts vulnerability that was released, the patch was released 2 months before Equifax was breached. And then Log4Shell, how many of you were around, had to deal with Log4Shell, Log4j? Okay, quite a few. If not, your time will come, and eventually you'll get that sleep back. Let's see. I guess to help you feel the fear, to lean into it a little bit, let's do a little thought exercise. Okay. Let's say you've got a service and it has 200 components, 200 dependencies. That's direct and indirect. And let's say 1% of those have critical vulnerabilities. Maybe it's remote code execution, something really fun, right? So 1%, you might be like, oh, that's fine. 1% is just 2. We might need to patch 1 or 2 things. For most companies, and maybe for companies you work for, so that's one service. Some companies might have 200 services, might have 500, might have 1,000 microservices, and each of them have these 200 dependencies with different critical vulnerabilities in just 1%. That could be 100, that could be 200, that could be a lot of critical vulnerabilities that if you're not looking at these open source dependencies, at the vulnerabilities they present, it could be a big problem. So moving on, what are the other risks we need to think about are licensing risks, infringement risk. So infringement is when you or your company violates a third party's intellectual property rights. And so if the dependency that you brought in violates that IP, knowingly or not, your code violates that IP, right? Just by using that dependency. And since open source software is almost always provided free and without warranty, that means your company doesn't have any contractual protections if something happens. If whoever owns that IP says, hey, you violated my property rights, they can come after you. They can come after the 100,000 projects that violate that property because they use an open source piece of software that violated it. And there are known instances of that where people have said, hey, we're going to sue these 8,000 companies, and those companies have to deal with that. Let's also talk about license restriction risk. So license restrictions, they can put conditions on how you use the software. Okay, it's basically, and let's see, yeah, restrictions on how you use the software, and including special clauses if the software is distributed, right? They might say, hey, you've distributed the software, you now also have to provide your source code. And so if no one is paying attention to those license restrictions, such as no commercial use, the company could land in serious legal trouble, right? And there are times where, hey, if you're just using this for internal only or non-distributed software, you might be fine. But if somebody's not paying attention to these risks, you might not be fine. And the other thing to note is every single dependency has its own license. Ideally, they're all using GPL or MIT license or something that is very, very safe, right? But the other thing is those dependencies have their own license, and their dependencies have their own licenses. And if nobody's paying attention, it could be problems. So if you want to present this to business leaders, right? here's some better business terms to kind of describe that legal risk, right? Costly and time-consuming litigation could result. The business might be forced to stop selling the product, either temporarily or permanently. The business might be forced to publicly disclose source code, right? If you're a SaaS vendor and what you're selling is just, hey, here's my software that's running, being forced to disclose your source code could be a business-ending event. If not, it could be very, very painful, right? For some of us, we might look at the source code of the companies we work for, and even if it wasn't a huge problem, we might be like, we would be very embarrassed to show that source code. Okay, and finally, the big one, having to pay monetary damages if you've violated someone's IP. Okay, step away from the legal stuff. Let's talk about quality. And I tried to find a batch of good quality pictures for this. So the quality risk. There's quite a few things to consider with quality. A project might have limited or no maintenance, right? Somebody might have created this piece of open source software, and then they're like, that was fun. It was a side project. I'm not going to maintain it. Maybe you found a bug in it, and you're trying to get it fixed. You submit an MR, and they're not touching it, right? It might just sit there, and suddenly, if your company really relies on this, suddenly your company might be the new maintainer, and you probably don't want to do that, right? The other thing, there's carelessness or ignorance of licensing and security issues, right? If you don't know the maintainer, which in general you probably don't, they might allow malicious merge requests, right? If they're not paying attention, basically their software could get hacked and then distributed out to everybody that relies on that dependency. They also might not be paying attention to vulnerabilities, to licensing issues. They might be pulling in something that's got a really bad license that's not for commercial use and not to be distributed. And if they weren't paying attention and don't really care, you now inherit that risk. Okay. Other things with quality, project abandonment. I kind of covered that on the previous one. And then breaking changes, right? Somebody could say, hey, I use this project mostly for my own use or for my company's use, and I just need to, I had to push an update to fix a specific bug or to add a feature. It broke a bunch of these functions, but since we no longer use them, it's fine, I'm pushing this update, and suddenly you have to decide, okay, how do we upgrade? We need some of these new features, but all those old features are broken. So now it's going to cost us a month, 2 months of development time, something like that. And these are just things that you may have to deal with, whether you like it or not, because you're using their dependency. Okay, so if you're starting to feel worried, then congratulations, and welcome to the world of open source dependency management. This is what it's all about. Dealing with that stuff on a regular basis and figuring out how to do it, have fun, and not get stressed out. And so now that we better understand the problem, what do we do about it, right? Where do we start if we want to manage and mitigate some of these risks? First, people. Get to know people, talk to people. You want to identify who else needs to be on board and who you partner with. So some of the people you'll probably want to talk to if you're interested in addressing these risks. Legal, they're almost certainly going to be interested in the license risk. They'll likely weigh in on what type of licenses they want to disallow, what might be okay with approval, and which ones are just totally fine. They'll probably also ask about what risky or disallowed licenses are currently being used, so they can address it, right? You want somebody from security if you're not that person. The risk from vulnerabilities is likely going to be managed by security or by a vulnerability management program. And at the very least, security is going to want to weigh in on how to assess and prioritize that risk. Engineering, depending on your organization, you might be in the engineering org, you might be adjacent to it, who knows. But in many ways, engineers are the users of open source. If you're going to start telling the users, hey, you can't use this, or tell them, hey, you have to upgrade all this, and even though they might say, well, it's not broken, it's working just fine, there's going to be issues with that, right? There's going to be concerns, and you want to include them early in the planning process. Finally, some additional potential stakeholders, IT, dev tooling, DevOps, whatever that group is called in your organization. Depending on how your organization operates, you might need to partner with them to add gates, to add tooling, to add enforcement mechanisms. So get to know people, talk to people. People are going to be keys in managing this risk. Okay, so we got people, we got processes and policies. So policy can help drive your process and also give you business justification for doing things that people in departments might not want to do, right? But if you have that business justification, if you have a policy in place, a policy is key. There's, let's see, an open source policy. Open source policy is great. Get it supported, get it enforced by cross-functional stakeholders, those people that you talk to. There's some guidance. There's the OWASP SCVS project. They've got great guidance on an open source policy. And then I've got a link there to some example open source policy from about 20 different commercial companies. And then you'll also want to figure out a process to do risk assessment and prioritization. This will save you a ton of time. If you've got a kind of a defined process and documented, it helps you avoid arguing over the priority of every single item, right? And there's a lot of different options for implementing it. It can be something official, like an open source governance group or a vuln management program. You might use SSVC, or it could be something ad hoc. That's basically, as long as you've got something that's a documented process. It might even be just a spreadsheet where you're tracking stuff. If you've got some organization, if you don't have organization, you're not really managing the risk, right? If you've got some organization, you can start to manage things. There's also some policy templates there, so I've got multiple links if you're interested. Finally, you're going to want a platform, right? You need to manage this risk, you'll need to build a data set and then start looking through it to understand it. You want to know what the risks look like. Are there certain repositories that are more risky than others? Is there 1 or 2 or 100 libraries where if you upgraded or got rid of them, they would fix a disproportionate number of your issues? When you have that data set, you can start to pull out that information and start to plan, hey, how are we going to address things, right? You also might start looking for tools or a platform to help you do this, especially if you start with a spreadsheet. Eventually, it's going to get too big to manage with a spreadsheet. Know that whatever you choose, it's not going to be perfect. There's going to be issues. You may even grow to hate it. I can name a very specific product that I hate because I had to work with it for 6 years, but I know it inside and out. And if I had to work with it again, I'd be happy to because I know how to make it do what I want. But basically, find one you can live with and move forward, right? Yeah, let's see. I've got a few tools here I've listed just to build that data set, right? You can just look through your BOM files. You can look at Dependabot if you're on GitLab. There's some built-in reports, and then there are some open source tools that can do this. OSS Review Toolkit is great. Point it at a repo, and it'll say, hey, here's your dependency graph. Here's the versions of everything, and here's vulnerabilities. And then there's tons of commercial tools that will. Once you have that platform, you can start to manage the risk, right? And so some of the previous tools, right, include that management functionality. There's also, if you've heard of an SCA tool, software composition analysis tool, those are for managing these types of risk. There's Sneak, SemGrep, Black Duck. There's tons of them, and there's OWASP has a nice list of tools that's pretty well updated, and it's open source, freemium, and commercial tools. Really great resource. Okay, so kind of wrapping up. So if you're new to this space, or your company is not looking at it, and you're saying, hey, how do I start this? I'm starting from scratch. What do I do? I would say first, build a data set and find a way to present it, right? Look through the BOM files, build a spreadsheet, grab one of those open source tools, and scan your most important repositories, your most important projects, whether maybe that's your web app, maybe that's your mobile app. Get a scan and start to look at the data set. What kind of vulnerabilities do you have? What kind of licenses do you have that are just going to be dangerous, right? And figure out a way to present it. Build a report, write a one-pager, build something so that you can show the risk to other people, so that they can easily consume, right? So you can show those stakeholders what's going on. And then you go talk to those stakeholders. Say, hey, this is risk. These are risks. Who's interested in working with this? Or let's make a decision on this. What do we want to do? Do we want to address this now, or in 6 months, or in a year? And then you just work together to define a path forward. Let's see. So and really that's a wrap. Let me say, your company is almost certainly using open source software, right? If so, you're inheriting the risk from vulnerabilities, from licenses, and the overall quality of the software, but you don't have to be scared. Managing the risk is not easy, but it is possible. And if it's something that interests you, it can be very satisfying. I mean, most of us are here. A lot of us are in security because we're interested in risk in one way or another, right? And we're interested in closing off risk, in addressing risk, sometimes exploiting the risk, because that can be a lot of fun. But usually that doesn't end up in a very long career path. But this can be fun, and whether you enjoy it or not, it can give you some job security. But in the end, I encourage you to go forth, conquer, and address those open source risks, and don't be scared. Thank you.
2 mics. All right, so here's numero uno.
Oh, you've already exceeded my Spanish.
Yep, somewhere behind you.
Yep.
Make sure the wire stays behind you.
Yep.
Pull it out, it's more fun.
Please heckle.
Make you feel like, oh, we can't see anything.
No, you can't see a single thing up there. Get up there. Go look.
If you're in the other room, you can't see anything. Oh, are they? That's a good question. Yeah, I don't know. I mean, because I like these guys. You know, to be able to talk to people. Where are you? Also valid point.
I've never had a headset like this before. How bendable is that? Very bendable. Okay, I just don't want to like snap it, and then you're like, yeah, fair. You don't get one.
All right.
You have to yell.
Glad you rehearsed on the fly.
Yeah.
And this is slides only. I see the notes. Is that right?
Well, at least up on the screen. Got a pin. It should, I theoretically get it, I guess. Maybe someday. You know exactly how it's gonna go? Yeah, there is singing. Is it online? Is it? Okay. I don't fucking know. I don't care. Going streaking! He's presenting. Mostly him. He did all the work. Yeah, I'm the pretty face. I'm the stage babe. The what? No, the next one. For me, my next one, at least. I don't, we're fine with cameras on this one. It was, the note for this one was like, so when we came in on the last talk, it was just a big picture of the guy and little tiny slides. So the only thing we're like, just put the slides up on the screen.
Well, he was walking around a lot, and so they
Yeah. Yeah. Fair.
If you're just standing,
Yeah.
we usually do slides big, and then if we do a
Yeah.
camera inlay, it's easy.
Don't have to worry about switching
This
for
one's
us.
yours?
What?
So it kind
You
of
probably
to your
don't
center
have
to
to
your
worry about
back.
switching for us.
That way
Just
the
because
wire kind of comes
they're
up behind you.
content-heavy slides.
Oh,
So-
yeah, and if it's content heavy, we
Yeah.
generally have slides.
Yeah. Content heavy, so just people will be reading them. That's all. What? Yeah. Yeah. And then it's and then tomorrow's the dome.
Camera hand slides on.
Yeah, just big slides, not big people. Should probably go hook your shit up. Yeah, exactly like that. Yeah, we're not gonna need to swap between it.
Once it's connected, then it'll
Yep.
a little less
It's-
blue.
Yeah, I know. And we do have two laptops, so I have an HDMI switcher that we tested already and it
Okay,
works
sweet.
fine. So I'll just hit it and then,
This thing.
yeah.
Okay, cool.
Well, no, we tested it on like seeing what's on the screen in front of us and all that.
Okay, perfect.
I assume that's just the exact same feed.
Like a little capture card, so it kind of blimps if the signal changes.
Okay, well, it's going to.
know how well your switcher was on that.
Well, if you want to test it real quick, we can do that. Ready? Takes a second because Mac. It'd help if my laptop didn't just die right now. No. Can't type with your thing in my way.
You just shove my stuff out of the way.
Yeah.
No worries.
Okay. Okay. So bright. So bright. Is it almost time? It is time.
Y'all ready?
It's up to you.
Oh, it's up to you.
Okay.
Ready? Yep. Okay. Testing.
I should probably test too. Am I good? Aye. Yeah. You were turned off.
Testing. There we go. Alrighty. Welcome everyone to the after lunch talk. Come on down. You're the next contestant to poorly manage your session state. There is a sing-along.
There is a sing-along.
Just to make everyone aware. So, I'm Sean Wallace. I'm currently the head of offensive security over at Caesars. I'm from San Francisco area. Just this is my third time speaking at SAINTCON, so thanks for having me. I love the engagement here. So,
yeah, Danny, I do lots of things, and the stuff I'm doing currently is employer doesn't want me to tell you about that. So, but if you want to know more, talk tomorrow. End of day.
alrighty. Standard disclaimer: these are our own opinions, not of any of our past, current, or future employers. Take us away.
Is that me already? I don't
No,
see
no, no. It's,
Oh, we're singing. Yes. Okay. So we'll give you one chance to hear the jingle and then try and sing along with it.
this is our kind of attack and presentation life cycle. Alrighty, so really the goal of our talk is we're trying to level up people here at this talk, right? We're talking about red, purple, blue, kind of the whole spectrum. We're going to go through some things you may know, but guarantee everyone's going to walk away with something you didn't know or a thought you didn't think about, something of that nature. We're also trying to emphasize how easy it is to do these things. We're not going to be busting out very complicated tools. We don't use Burp Suite or anything of that. We try to stay away from, hey, it really is simple, really just knock it out. So, over to Danny.
Yeah. So when we start talking about sessions and web sessions and all that stuff, you know, this is pretty much like the flow of how you deal with single sign-on stuff. And I'm not super interested in understanding the flow here, there, step A, B, C, D, all that stuff. But the real thing that I kind of want to emphasize there is when a web browser is authenticating to a web app using single sign-on stuff, it's going to interact with the IDP. It's going to then get the authorization from the IDP and then send that over to the web app itself. The web app never actually talks to the IDP in that process whatsoever. And so pretty much once the IDP says, yep, they're authorized, here's the authorization token, hand that over to the web app itself, you can do all that. So that exchange between the browser and the actual web app or SaaS app itself, that's one of, to me, one of the key things of, you want to steal the data coming off of that. And so that's pretty much kind of what I'm trying to say with kind of this slide.
The other thing, I like to call out is once your IDP finishes that authentication, they never talk again. It's just, thanks and move on. Now you're talking directly to that SaaS site, and it's handling all of that session state now.
So to me, that's the stuff that you really want to steal and is actually more interested in from an attacker's standpoint. The video off of the slides?
Yeah.
The presenter video, because content heavy slides.
Right. Alrighty, so we'll talk quickly about why our bad actors may do this. Financial gain ransomware, right? Why are they going to attack SaaS sites? They're looking for ways to get into systems. Hey, can I ransom your whole? Can I use tools to ransom your whole environment? I may know something about that. Right, data theft, they're also going after company data, intellectual property, right? Your customer data, your employee data. These are all things of you got to kind of consider what are these SaaS applications giving access to, and then your backdoor access. This is kind of like the target reach, right? Hey, they got in through an HVAC, now they can come in through that. You have to consider, what do all my third parties do and what do they have access to?
Ready to sing? Mike?
So we did have a bit of a competition with our other neighbors here who was louder. So make sure we get in on the singing.
Guys are failing so far. Oh, this is my slide. It has my name on it. Sweet. Cool. So kind of some of the reconnaissance of when I'm trying to look for things that are using kind of this single sign-on SaaS kind of base stuff is I'm looking at a lot of public data, certificate transparency logs, and like for those who aren't aware of, like whenever you're creating a TLS cert through Let's Encrypt or something like that, all of those logs of the certificates that are generated get published out to the world for anyone really to see. So you can start seeing as people are standing up this kind of infrastructure. So if I'm looking to potentially attack an organization, like what kind of, IDP are they potentially using? Are they using Okta? Are they using something else? I'm going to look for things like TLS certs being issued for company A at .okta.com, looking for anything like that. In addition to certificate transparency things, you can do lots of passive DNS, a lot of passive DNS providers out there. So those are some of the ones that we like. Silent Push, but because they've been doing a lot of really cool stuff lately. But they're listening to like basically all DNS that's going across the internet and aggregating it out. So then you can, again, start searching through those kind of logs to try and target some of these kind of services.
What I like to do, kind of from that enumeration side, is a lot of companies, in this case, are going to use Zoom, but if you pick out any of your SaaS sites, they tend to brand that title, right? So it could be, I put some examples here, right, of NFL.zoom.us or something of that nature. You can either do this with DNS, although a lot of them now have moved to doing something with Anycast, so they respond to anything. But as you can see with the pictures here, they're kind of showing that they still have branding up, so you know that they're customers of these if you want to figure out what they're using. But I think I pulled down like a Fortune 1000 list and just pulled all the domains out for each of the Fortune 1000 companies and just did a for loop, right, against DNS and came up with a list of popular SaaS sites, and I was able to figure this out in 20 minutes or whatever. So
I had an interesting story about that. Literally yesterday, I had a coworker ping me and goes, "Hey, I had a weird LinkedIn thing happen to me. It's some sales guy at some company reached out and said, hey, I see that your company is looking into products in this space that I sell. Can you point me in the right direction?" And we're like, yes, we are actually looking at those. And I am speculating that they saw the infrastructure stand up for us POVing their competitor. And so like, yay, that was fun. I'm like, that's a good way to get blacklisted from us ever talking to you ever again.
Yep.
But yeah, those kind of techniques are all kind of the same thing.
Cool. So if you're in the purple team or blue team, log review is a really good way. I love looking through, the next-gen firewall logs or your proxy logs. You'll see all those SaaS sites that people are going to. You can sort them by usage, right? And you start to get kind of the sense of what's being used. But you could have just also asked the IAM team. So, it's just, they're actually quite friendly. Just, hey, can you show me everything that Okta's using or whatever, right? And they can produce a list for you, and you can start to kind of threat model on that, which is our next topic here. So, when you have this list now of all those SaaS sites, you're looking for those high-value targets. You're looking for things that, hey, yes, things like AWS, Salesforce, Terraform, right? Things that will have access to all these systems, where if you attack them, then I could pull ransom down on anything. Or those ones that have high value target for data, right? Your Salesforce, ServiceNow, Slack, right? Any of those things. So you're also kind of looking at, well, do I have controls that allow SaaS sites already in place? You can deploy those both on the IDP, and you can deploy those on the application themselves. You can start to understand, well, if some of those are controls in place, right, you start to narrow down the threat model as well. What do I need to look at? What do I need to focus on?
Ready? Ready?
Alrighty. So as we start talking about our session cookies here, we essentially are talking about the two sets of cookies, our session cookies and our persistent cookies. So session cookies are intended to only last as long as the session is in the browser, whereas your persistent cookies are going to last throughout. They're going to be stored on disk and whatnot. Session cookies should only be stored in memory. So they're all vulnerable kind of to the same thing. Your info stealers, your attacker in the middle, your system compromise will kind of go through those. The session cookies, I say, should have the session flag noted. We've run across a lot of cases where they don't, which is pretty interesting and just leads to complications, right? Persistent cookies don't have that. That's why they persist, right? I went through experience of upgrading my Mac recently, and it's just all those cookies get moved over, and it's just amazing, like, oh yeah, everything just started to work, right? That's because of those persistent cookies. So, think about what are those systems that you access that probably have high data that you never have to go through that login process for, because it just knows. And that's where you start to become to this worrisome, oh wow, I have access to these things. So session cookies are ideally on financial systems, your IT systems, your InfoSec systems, anything that's high value target should have a session cookie. I find it funny, like, the banks make a big deal out of it. Oh, save your, username. Like, oh, that's saving me a lot of time, but that's getting stored in that persistent cookie then. Things like Slack, Confluence, Jira, never have to log into those, right? And there's been plenty, I think Disney just had a breach, right, with Slack again, where a lot of the data from there was able to be used. So think about that, of what's stored in those systems that may be valuable to an attacker. So a very simple way, just how to view cookies in developer tools, right? Just go to developer tools, application cookies. You'll see them right here. This is an example for CrowdStrike. I like using an extension to do this. Cookie editor is the one I usually use. And it just makes it easy to import, export. We'll show kind of a demo of that later and how easy that is to use. That's kind of the point, right, of it's 2 clicks, right, to get your cookies out versus knowing a ton of math on how to do this. This is just an example. The one on the left here is your memory cookies. So you see there's 7. And then when we look at the database on disk, there's only 3. So you can see, 4 of those are labeled as session, and those 3 that exist are here. We'll go over a little more detail of this in a couple of slides. And here we go again.
So good.
Thank you.
Sean got all of that done. I did none of that, so.
Credit goes to my daughter, Ashley, for doing the animation. But
So when we were trying to talk about kind of the weird and like not so official history of like credential theft and like stealing passwords and cookies and like good luck actually finding something out there that's like definitive. So we tried to like throw a bunch of stuff on here to just kind of see just kind of what it looked like and pick out some of the bigger events that we could see. Phishing term, coined in '95. Zeus was a big one that's still, we're feeling the ramifications of that even today. Malware that was developed and then source code was put out and then billions and billions and billions of derivatives and everybody was using that source code. You got into more advanced stuff. I was around during like all the Firesheep stuff, which was tons of fun. Essentially what that was cookies being passed over unencrypted HTTP and people on Wi-Fi going, oh, I shall take that cookie now. Thank you very much. I'm going to log into your Facebook account. Fish kits, again, we were trying to figure out how far back like actual fish kits are. And for those who don't know or in the malware space, it's essentially like a zip file that's pre-compiled fish site. You just drop a zip on a compromised web server, unzip it, point everybody to it, and then all of a sudden you're phishing credentials. 2011-ish was when we kind of saw the first references to that term. Team Cymru had a blog post that they said they were collecting fish kits all the way back in 2011. Stuff like that. And then you get all the way into kind of where we're at now is a lot of the Evil Engine X stuff, which is really spurred on by a lot of the MFA bypasses. And everybody knows what that tool is just kind of because of that. And essentially it's bypassing MFA because it's stealing your cookies. You're not actually going through any kind of authentication procedure, and generally lots of things, if you have a valid cookie, they don't care where you're coming from, country, IP, anything like that. It's already been a validated session. So there's a lot of work being done right now in the industry and in various different vendors on detecting this kind of stuff, but it's still very much a legitimate attack vector. And I think I saw a blog, SecureWorks, a little bit ago. I think they said 70% of all ransomware compromises came from like this kind of info stealer and or attacker in the middle proxy kind of stuff. So super prevalent. Really, really basic examples, just because we need pictures, but these are some credential phishing fish kits that you essentially, like I said, just a zip file, you drop onto compromised infrastructure, start pointing people at it, and most of the time you enter credentials into it and it'll email them out to the attacker. In some cases, they actually just write it to disk, and when you have open directories enabled on that web server, you can start getting all of the phished passwords, which is lots of fun. I may or may not have done that a couple of times. But yeah, so talked about it a little bit earlier, but kind of some of the info stealer stuff. I think this is one of those things that I don't think a lot of people necessarily talked about as much as they should have, and it's becoming more prevalent with this cookie theft kind of stuff. But just the devastation that can happen, just a really basic info stealer is really crazy, just because it's so low tech. Like if you write an info stealer, it's not that much more work. Like it's way less work than something more exotic or sexy or stuff like that. But and you're seeing all the big off-the-shelf info stealers that you can buy or get anywhere. Like the big component of them is to steal all of these cookies and credentials stored in the browser and using all of those. And so you can kind of see that. I have some examples. I don't know how well they're showing up here. But there's whole marketplaces that are selling this data that are coming out of info stealers, and they're doing the legwork to actually go through the data that's coming out of those credential stealers to tell you what sessions to what services does this actually have access to. So then you can start potentially as an attacker buying access to very specific services that are active and valid because they're current active sessions that may or may not have been timed out yet. So super cool, I think it's super interesting. But
I'm kind of circling back to the persistent cookies. You just acquire the cookie file. Actually, it's the next slide has the locations, but you then need to extract it out of the database, which is SQLite, and then you will have to decrypt it as well. There's plenty of tools to do that, but this is just demonstrating how easy it is. Just pull the file out. I recommend you all just give this a try. It's very simple.
yeah, just a SQLite database.
Yeah, and that way you'll kind of understand of like, well, if an attacker were to do this, this is how they would go through that same process. Alrighty.
Oh, before you do that, all the major like C2 stuff, that's all built in. Like they do all that, like out of the box. So.
And we're moving on.
Almost at the top of the hill.
Okay, so now we're going to talk about some of our application security controls, and this is where I think it gets exciting for me and kind of a red teamer, right, coming in about how, what should I be testing, what can I do? So.
Oh, he nerds out about it.
So yeah, we talked about the session cookie plenty. So we've heard this in one of the other talks as well. There's an idle timeout and absolute timeout, right? The idle timeout is how long has your session been idle, and I'll kick you out after that. The absolute is, okay, well, how long? Well, I'll let you log in for a day, and that's it, right? Keep alive protection, well, that's important because you can defeat that idle timeout using keep alive. So your application is able to detect that or understand that that's not real data. That is a very good thing and will not be prone to some of those methods. Being able to revoke the session. Well, what happens if in certain conditions, we'll go over a couple of examples of that, but what happens in these conditions? Does the session cookie actually get terminated like it should, or does it not? IP restrictions, we talked about, you can put those both on the IDP, but you also should put those on the application. Because if you do a passive cookie attack or something, well, the IDP isn't even in the equation anymore. It's the application that matters. And a lot of people just stop at thinking that the IDP told them everything was secure. So why do I need to do anything more on the application? Simultaneous session login. Why do I have somebody logged in twice, right? Should at least notify or kick the other person out. Or system integrity. Am I the same network system browser? In the talk yesterday, they talked about, I think it was cross-system browser detection from Chrome, right? Of doing similar things like that. Or a lot of some applications have this built in where they're able to detect that themselves. So for our example, I call this the working example. I use box.com, right? And the two methods I did is just like a file close. And yeah, that cookie was revoked. Had to log back in when I went to the site again. Second example, I just did X on the either upper right or the upper left on a Mac, whatever, right? And of course, the cookie was revoked again. But then I go over to CrowdStrike. And I should just note, I'm not throwing shade at CrowdStrike. I did all this testing before the incident happened. So it just happens to be a good example that I wanted to keep. But when I do file close, that cookie's revoked, but when I X out, that cookie is not revoked. I'm like, what's going on here, right? So that cookie is gonna stay valid up to their 1 hour idle timeout. So, a hacker could steal that cookie and, you as a user think, hey, I logged out, right? I closed my browser, I closed my session, but no, you didn't. So, it's just small things like this is all an attacker needs, right? Is to be able to, understand that I just need to steal that cookie in that race condition, that time window, and now I have access to CrowdStrike and think of what I can do with that. So this is an example of that cookie from CrowdStrike. You can see the ID cookie is the session cookie we're talking about. You'll notice over here on the expiry, it should say session, and it does not, right? So it is now a persistent cookie instead of that, meaning it persists when you close the session out. So the application, when you did file close, terminated it, but it didn't do that when I closed the window out. So this is something that I have been in touch with them to fix, and they have said it is working as intended. Don't we love to hear that? So But yeah, there's more, right? So I talked about the keep alive. So using any of these web extensions, right? You just click on them and they keep that session open. I think I stopped testing after 7 days. There is no absolute timeout for CrowdStrike that I am aware of. Maybe it's 8 days, but and again, same result, not a security flaw, working as intended. So, now we kind of think about this, well, if an attacker was able to steal that cookie, CrowdStrike's a high value system, they can get access and run commands on every endpoint it manages. There is a real-time response thing that you can enable that requires MFA, so props for them for doing that. I am not sure how many people are aware of that or have that enabled. It's not enabled by default. I just learned about that, and so.
Really hard to do in automation-heavy shops.
Yes, exactly. That lack of session revocation means that cookie's going to be valid, right? And that lapse, that no absolute timeout means an attacker could be in there for nearly ever, right? As long as that the cookie's valid. So, I do want to call out that in InfoSec, we like to blow smoke here, right, and say, well, there is that race condition. So that's my only thing, is you do have like an hour before that idle timeout to steal the cookie. So there is some difficulty to do this. So it's not the end of the world, but there definitely is a lot of room for improvement here as well.
Kind of almost waiting for more offensive tools to actually incorporate that and start, like, we're going to ping all of the sessions that we currently have active every 10 minutes.
Yes.
Try and keep those open.
Right. Exactly. I'm surprised that isn't already incorporated in.
Yeah.
So yeah, we'll talk about logging now. So, every vendor I talk to gives me that perfect world state, right? Yeah, I'm sure you're logging everything. I'm sure you're logging all your SASs. I'm sure you're doing this, right? And I've never seen anyone log all of their SASs. It's just nearly impossible. Every SIM team I've worked with is overworked, right? And just doing their best trying to onboard what they can. Now, as more things are moving to the cloud, though, too, I have a lot of people coming to me saying, hey, we need to reduce our logs to cloud. Why are we sending all of these systems, right? So in a resource shortage world, in a cloud expensive world, right, you have hundreds. My last job had over 500 SaaS sites that they were using, right? So you really got to kind of look at it and say, well, what are the ones that are important? Where do I really need to have logs and do forensics? So that threat modeling comes really into play here of understanding what are those systems that are important, which ones should we focus getting logs on. I've implemented like a kind of a 3-tier system of tier 1 are the ones, yeah, absolutely need these. Tier 2, maybe just the security logs, or maybe some of these. Tier 3, we'll contact if we need something. I recommend doing some dry runs, right? Some tabletop exercises, call them up, say, hey, I need these logs, see how long they take. I've been in, IR situations where it's been past 72 hours, and you're just like, this is ridiculous. We have an ongoing incident. We know we need to know what they did, and you're just not getting that info. All righty, we're moving on to the next section. All right, and now we'll talk about some mitigations and controls. So this section's fun. We talk about a lot of, new things that are coming. So we start off with our IDP, right? Our SSO solution, most popular Okta, Ping, or Intra-ID, right? These solutions definitely like to tout whatever, that they are an all-in-one solution. Hey, this is everything you need, right? And we quickly find out that that's not the case. There are very few scenarios, though, if you use if everything lines up, it is a good solution. Mm-hmm. If you're using this, if you enable Okta Verify, if you enable Universal Logout, you use our ITRP, right? But it just becomes so many requirements to get into that window. And then if you use one other setting, you're, again, misaligned. So some recommendations, right? Of course, you could be doing pushes. You could be enforcing MFA with Authenticator, right? You may be using a passwordless solution, either with Okta or like Hyper or something. Or you could be using YubiKey, which is one of the better mitigations to a lot of these attacks. So you ask these questions of yourself, right? Do my users need access from external? Are they only accessing from internal systems? Or do I have a mix, right? This is going to help you kind of define what that architecture should look like. Do they need to be accessed off network, right? What about my break glass situations? Do I have an always-on VPN solution that I could route them through, or am I using a SASE solution? So what's really interesting about some of like the SASE solutions, in the cases that we talked about where we're not getting logging, you're not even seeing access because it's going off network, right? But if you're routing it through like a SASE solution or an always-on VPN, at least you're getting the visibility in your firewall logs, and you can go say, oh, now I know on this date this user went because the firewall told me, where you may not have any other logs if it's purely SaaS and you have don't have an always-on VPN. So we're seeing some combination solutions. I think Microsoft has like a really good solution where they recommend using Intra-ID and then their CASB as well as a SASE solution, and you're kind of getting the best world of this of, okay, I'm getting the IDP, I'm getting some CASB protection, and then I'm also routing that traffic to where if I don't have integration and visibility, at least I can see it. So, and then when you're looking at those applications, what are the applications with high users or high target value, right? High users, like every user in the company uses this, versus, oh, there's 5 users and using Jamf, right? Do I really need, what's the likelihood an attacker is going to target those 5 users? And they're also in IT, so they're probably a little book smart when it comes to security, let's hope.
You hope.
So, and then what applications contain sensitive data, and do you tokenize it or not? We've seen a lot of investment in protecting applications that have tokenized data, and I just scratch my head and say, well, I would much rather focus on the ones that don't. But nobody asked those questions, right? And we ended up with, oh, we just knew it had data, so we invested our time there. The enhanced protections that we're seeing from the IDPs, they definitely have something called phishing protection that they keep trying to sell. They claim it has this trust between like authenticator and user identity. Again, with Okta, I think they require Okta Verify with this, right? Which only works with like 9 apps. They probably have more since Octane, but their conference a couple weeks ago. But user behavioral is a really cool tool to use in this scenario. On the next slide, I think we talk about a new term, ITDR, right, for identity. And what we're seeing here is definitely up and coming. We're seeing the application work with the IDP, but then also working with the application and getting the log somehow, either through an API or an integration, right? And they're able to say, oh, well, Sean logged in here and his IP changed over here. Well, let's revoke his session now and do that. Some of these are your IDP solutions, but you'll see other solutions are coming up that are third parties that are able to do this. These are some of the examples of some of the things that they can detect. It's pretty cool tech to kind of see this work in action. Supposedly they can detect things like passive cookie attacks and things of this nature, but I haven't seen a lot of success with them yet. I just haven't seen a lot of demos of them yet. In the cases like Okta that I mentioned where I have, it is a very, hey, you have to use one of these 9 apps. And I'm like, I don't use any of those, so thanks. Thanks for playing. So back to the application protections, right? These are all important. These are things that you should be asking your SaaS vendors or testing yourself, right? And pushing them, just like I'm constantly pushing CrowdStrike, right? Of, hey, why can't I modify my timeout? Why can't I set an idle or absolute timeout, right? Why aren't you revoking your sessions like you should? Can I enforce IP restrictions, right? Why aren't you doing simultaneous session logins? What can you do about system integrity, right? The biggest problem what we all have with these, with 500 plus SaaS apps, depending on your company, right? How are you going to centrally manage all these? And that's the biggest pain, is you're having to manage these individually, one by one, and it is a nightmare. CASB promised years ago. Where are you, CASB? If anyone's from Palo, they're probably crying.
Wait, there is animation.
Alrighty, we're gonna hand things over to Danny for some demo time.
So if any of you have ever played in any of this very basically, this is going to be boring. It's very, very intro level kind of how some of these tools and this process works.
And I think, you know, the point that I wanted to come across by doing the demos was also just showing how easy they are for you to set up. For instance, for Evil Jinx, right? I think it took us, we did our demos on our own to test it out, under an hour for each. And I was like, that was a great investment of time.
Yeah.
I learned so much by going through that process of how an attacker would do it, how they register certs, right? How that's all incorporated into the tool. So.
Yeah, totally. So I'm starting out, I have this really, really basic, one of the best domains that I own, hackerpirate.ninja, with some yay fun AI generated stuff. But essentially, I'm going to show you that, nope, we're not going to be authenticated to it. Hey, try and log in. Doesn't necessarily work. So then we're going to come over to this guy. So then we're going there. Let me try and blow that up for you. I don't know the command. There we go. Cool. So then we're going to sudo build Evil Nginx, fishlets, Hackerpirate Ninja. Nope, not give it the directory, not the actual file. So I have this fishlet already enabled. Again, it took I had 10, 15 minutes to configure it and just try and get all the values into it. I'm not going to go necessarily into how to do that, but essentially it's launch it. We already see that it's enabled and it's visible, and then we have a host name. So I'm going to lures, get URL 0, and so then it's going to give us this copy link, so you can kind of see pointing to HPN hackerpirateninja.malicious.actor, which is again another one of my absolute favorite domains of the number of them that I own. You hit that, and it's going to proxy to that same WordPress login page. We're going to see detection authorization, intercepted WP login, blah, 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 blah. All that good stuff. So we're going to authenticate to it. We're getting into WordPress. Like, change your password. It's garbage. Weird. So you can see, like, you hit it, and it is the actual same HackerPirate Ninja site. We're all in there. But then we, run over to here, username, Danny Hunter 2. And you're like, cool, all right, great. So then what can we do there? Sessions. Oh, look, I did this already before. I didn't clear that out. Cool. So here, it just drops out all of the cookies. You essentially just copy them. And then from my Kali, my attacker box, we're going to essentially pirate.ninja. Again, we're going to run to WP admin. Again, we're not authenticated, but we have the cookie editor thing in there, so we can kind of see the cookies that are currently existing, values, any kind of thing like that. So Sean and I kind of debated before this. I like to just delete everything out. He just dumps them all in. But then you hit import, and it just takes that JSON snippet out of Evil Nginx. You hit import. You hit WP admin again, and voila! We didn't authenticate on a totally different system. Now, I am coming from the same IP and everything and all that, but that's irregardless. It's just pretty much to show like how easy it is to steal those things with the tooling that we have, which is offensive tooling's gotten so good.
Yeah, and there's so many fishlets that are already created. You just literally go to the GitHub site, and there's hundreds of them out there that people have posted on, so you don't even have to create your own.
Yeah, right. So, super kind of neat. I think that was it. Did
Yeah.
you want me to show anything else? I don't remember.
Sure.
Yeah. To who? Torvalds? No. Okay. Okay. Yeah. So, yeah, everybody gets hit by this. Like, it's super prevalent. So I'm not surprised that anyone with like any kind of. Yeah. Yeah. Lots of people. Just kind of reiterate for everybody in the back. Just lots of high-profile individuals get hit by this kind of thing. I heard a couple years ago, I follow automotive YouTube, and all of the big automotive YouTube pages got hit by this, and people were taking their channels and deleting the videos and all that, and they're like, we're not IT guys, and I'm like, I know exactly what happens there.
And one of the things that I like to reiterate is on the phishing kits, you log in and credentials, and you're like, oh, it didn't work, the page is broken,
Yeah.
like I just lost my credentials, and you kind of have that moment of dread where, like, oh, I shouldn't have done that. But when you're using a tool like this, it's proxying everything, so it looks.
It doesn't look. It is the actual site.
It is the actual site.
I can go make posts to it, all coming from that malicious domain.
Right.
Full functionality exists.
And we all know how the typo squatting works, right? How easy it is sometimes to miss that. But the big thing is you expect it not to work. So when it does work, you're like, oh, everything must be fine.
Yeah, you just have to notice, oh, well, it's a different domain, and I didn't get any TLS errors, and all of that kind of stuff. But with Evil Engine X, like, they've solved all that for everybody. Like, you tell it, like, in your fish kit, in your config, and you go, these are the domains that you're going to point people to. And it goes and registers all those TLS certs for you and just automatically uses it. Like, there is almost zero effort from technologically from using it.
Yeah, any other questions? We'll try to see people. It's very bright up here.
Yes? Have you played with, the question is, have you played with Google and gotten past their reCAPTCHA stuff?
No, I stayed away from any of the ones that had like heavy traffic, because I was just like, well, they obviously are fighting this battle with Google, and there were Microsoft was one that they just seem to be constantly fighting this. So, I initially was kind of targeting my higher value systems, right? Of what do I need to protect in my company? And we have a lot of extra protections on Google just for that reason, for MFA and things, to avoid this. So I didn't spend much time playing with it.
A lot of those big platform vendors kind of stuff are doing a lot of work to try and detect all this stuff. I know in trying to set up this stuff, I was like, let me screw around with my LinkedIn profile. That was a bad idea. They're really good at detecting that, and every single time.
It worked for me, though.
Yeah, how long ago? And so every single time I tried to hit my LinkedIn profile through Evil Engine X, I had to receive an SMS MFA. I had to click in the link in the email. It just kept going, and it required me to change my password every single time. And I was like, and I even said to him, I said, wow, okay, I haven't tried LinkedIn on this stuff before, but damn, good job.
Yeah. Any other questions?
It's hard to see hands. Can't see anything up here. No?
All righty.
Cool. Well, thank you all.
Thank you.
Yoink.
Okay. Do you want to try it really quick before we get started? That is really close to my mouth. Maybe that's good. How we doing on sound? You got it on? And go. Whoa, that is really loud. Hi, everybody. I'm guessing you can hear me in the back because I can hear me echoing off the back. All right. All right, you can hit the mute. Thank you. Yeah. Hopefully everybody knows me as SJ already. Is there anybody here who doesn't know me already? Hi guys, nice to meet you. Welcome to SAINTCON. All right. Wow, that is so bright. No, it's okay. You don't have to change it. I'm just... If it gets you a good picture, we're good. No, I'm good. I'm good. Really bright. Is this my stop point here? This marker?
It could be any point. Could be your stop marker. Any point you like.
Okay.
I was gonna basically adjust the camera to however you,
But we need to decide now?
Yeah, I could do that now and then.
Well, let's count this stop point as our marker here. Do you want me to stand there so you can see it? Thanks. $8.26. What is that? Just a piece of plastic. You got a trash can? Sweet. For the tinfoil? I don't know if that's happening today. I don't know if that's happening today, but I actually don't ever know that that's happening. It just happens. So if it does, bonus for you. How many of you have seen the foiling? How many of you participated in the foiling, Dave? That is an iron print. Did you see that?
I did see that, and I didn't question it.
Just like, why is there an iron burned into this platform?
You know, we're middle of setting up the stage, and I think that would be perfect if you could. I got them to move it just a little bit down for the lighting.
Okay, yeah, that'd be great. Thank you. Okay. Well, we're starting in 3 minutes, so we got a minute to spare and everything. Before we get started, how many of you have heard me speak before? Raise your hand. There's no volume. This is just me. Do you want me to speak louder? How many of you have heard me speak before here at SAINTCON? Okay. Yeah, go ahead. If you couldn't hear me before, how many of you heard me speak at SAINTCON before? Raise your hand. Okay, a couple first timers. It's going to be fun. I hope it's going to be fun for me. I hope it's fun for you. This is going to be an interactive session, so please feel free to participate during the presentation. This isn't me just lecturing to you. I do want you to learn stuff. And we'll get started in another minute here. Now it's flickering. Oh, yeah? That's fine. Yeah, that'll work. Thank you. Hopefully it'll help for the next person, too. Maybe everyone's just looking down at their slides or something. I don't know. Okay, by my mark, that's 2:30. Are you good to go? Everyone out there good to go? We ready? Okay, welcome, everyone. My name is Seth. I go by SJ. How's everybody enjoying the conference so far? All right, great. Glad you're having a good time. Can we put the slides up over there, too? Can we put the slides up on the big screen? Because I realize now that I can see them, but you can't. You might want to. Okay, today we're going to talk about privacy counter surveillance. How many of you are here for that talk? If you're not raising your hand, you might be in the wrong room, because that's what I'm talking about today. Welcome. I've given a number of talks about privacy and a workshop about privacy. A lot of it's online privacy, and today we're going to go a little bit more, I don't know, just less internet and more physical, I guess, if that's okay. Hope that's what you're expecting. So the first thing I want to talk about, I went too far there, is what is privacy counter surveillance? And for me, this is identifying what surveillance is taking place from a privacy perspective, specifically regarding me and myself, my family, maybe even my organizations. There are lots of things out there that are trying to grab information, and we should probably talk about that. Surveillance is intended as data collection. Think about that for just a minute. Many of you probably are in roles where you collect a lot of data, and it might be data for your organization, it might be data that helps you to run a business or to provide services to whatever government organization that you work for. You might be collecting or information for your organization against threats. How many of you are threat hunters? Couple of you, like, collecting that information is a big deal. Making sure that you have that information. I think there's something going on with the mic. Can you hear that? Is it different for you guys back there? There we go. Okay, great. Anyway, so surveillance is by default a data collection activity. And I want to talk a little bit about for what purpose? What are we working towards as we're collecting information? And what do people want? What do they work toward to get with their surveillance? Any ideas? What do you guys think? What kind of surveillance do you see? What are the motivations that people have for collecting that data? Advertisement, and then ultimately some sort of monetary gain. What else? Law enforcement. Okay, we're not going to talk a lot about that today. Personal revenge. Okay, yeah, that's a nasty one. Understanding your population or user base or customer base. Yeah. Metrics. Tell me a little bit more about metrics. Okay, so collecting demographics perhaps on a specific customer base, maybe to help your product perform better. Great, yeah. Other ideas? Can't see very far back there with those lines. Okay. Many of you might be familiar with the term threat modeling, and we're going to talk about that in a slightly different context today. How many of you have thought about doing some threat modeling for surveillance for you in your life? I'm seeing a lot more hands than I expected. Okay, how many of you have done it? Not just thought about it, I do it. 3 of you? Good job, guys. We're going to do a little bit of that today. I hope that you can have some fun with that. But ultimately, when we talk about surveillance and maintaining your privacy, there are so many different things that you can do to improve your privacy and to potentially combat surveillance. But it sort of depends on what surveillance you're likely to encounter. And many of you might have some experience with this in your security careers, where it's very difficult to secure everything. And you end up needing to prioritize which things you're securing. Privacy for surveillance is the same kind of thing. You want to make sure that you have an understanding of which things are the biggest priority for you and target those first. All right, so during the activities that we're going to do today, I would like very much for you to be thinking in your minds, how would I model out the threats toward my privacy and the things that I'm concerned about, and how would I prioritize that for myself? I'm going to give some examples today, but these examples obviously show my viewpoint, and I don't necessarily believe that my viewpoint is the viewpoint that everyone should hold. We all have different experiences, maybe different priorities, different views. That's okay. I welcome that, but I do think that it's worth considering what this is like for you. Any questions about that before we move on? All right, so for those of you who have never been to my talk before, welcome to my favorite part of the talk, which is story time. We're going to talk about a couple specific stories of me encountering some of these things in the real world. The first one is when I went to a meeting and I stayed over at a rental property, a meeting for SAINTCON, preparing for this conference. Stayed over at a rental property, and while I was there, I found an electrical plug that plugged into the wall, and then the cable went up and down and back into the wall and disappeared. How many of you think that's a great sign? I see one hand out there punking me, thank you, and everyone else snickering. A little bit worrisome, perhaps. All right, story number 2. Checking into the hotel for this conference, and perhaps some other hotels as well, a little thing hanging on the bottom of the TV. I walk into the hotel room and my son says to me, "Dad, what's that thing?" All right, so now that we started with story time, let's start with some examples or sample taste buds of some places where you might find surveillance that will help you to think about the way that surveillance works. How many of you have a doorstep? A couple of you. All right, great. How many of you have surveillance on your doorstep? Maybe more of you have surveillance than a doorstep. Okay, great. What kind of surveillance do you have on your doorstep? Video doorbell. Okay, what else? What's that? Cameras. Okay, I thought you said hammers, and I'm like, wow, that's intense. Shotgun. Probably, we're not going to recommend that. Motion sensors. Okay. Audio. Yeah, sometimes the audio and video are paired together. Some of you might have a doorbell where you can actually interact with someone even if you're not at home on your phone. Like, that's a normal thing to have. Lots of people. Yeah, go ahead. A window. Okay, yeah. A little old school. You can do some surveillance that way. Yes. Tripwires. So, go ahead. A big dog. Yeah. There's some interesting sensors in that one. Yes. A very little dog. Maybe some of the same sensors, but a little bit less bite, maybe more bark, right? So as part of this, the preparation for this talk, I was working with my son on one of his school projects, and we did some engineering. We wanted to create a doorbell ditching de-incentivizing device, the 4Ds. And it was a sensor that was tied to the doorbell, and when the doorbell rings, it immediately fires a signal to a device that would shoot out a cloud of colored dust, like chalk, but it would shoot it away from the door. So if you happened to be the person who rang the doorbell and was actually there to see us, you'd see a cloud of puffy colored something behind you and be like, what was that? But if you're the person who's ringing the doorbell and running off, you're going to be pelted in the back with a color that you got to explain when you get home. So it doesn't have to be necessarily a commercially available thing. And I think some of you have seen some of the incredible things that have been created here. Maybe some of you have seen the mini badges that are being shared around the conference. Creating your own things and making your own devices with some of the things that are available to you today, it's a real thing. And when we think about how you maintain your privacy and maybe how others are implementing surveillance, that's something that I think is worth taking into account. All right, let's talk about the next one. How about retail establishments? Is there surveillance there? What kind of surveillance do you see at retail establishments? Cameras? Yes, okay. What's that? Loyalty cards. Heat mapping. Credit card machines. How about Bluetooth and Wi-Fi tracking? Beacons, yeah. Door guards. A little bit more human, old school, okay. Amusement parks. How many of you have been to an amusement park lately? You have an experience? What was it like? All right, anybody else? Yeah. They give you watches. Yeah. There's some good things to that, right? Which is if you happen to lose a child, location is pretty easy for that sort of thing as long as they still have it on them. But you're also under surveillance, of course. Any questions about those tidbit samples of things that we're thinking about today? All right, yell if you're in the back if I don't see your hand. All right, so let's talk about some common types of surveillance. First, I want to say that surveillance generally comes out of what I like to call the human experience. For those of us in the room who are humans, we have a pretty good understanding of what it means to be human. You've experienced that for a long time. And so we're good at emulating the human experience. However, we can potentially replace some of that human experience with a number of devices, or perhaps even augment that experience with devices. For example, the senses of the human body, generally categorized as 5, but probably lots more. Hearing, using the ear, right? We have emulations of that thing with microphones and audio recordings. We talked a little bit about that. We also have eyes where we see things, and we have devices that emulate that with both photo and video. Those are perhaps the most common kinds of surveillance that you see. And the reason for that is because they're like humans. Now, let's talk about things that maybe humans are not so good at, right? We're good at seeing things and we're good at hearing things. And we're going to do a live demonstration. I need 2 volunteers from the audience, and I promise you that I will reward you with something cool at the end of this talk if you're one of my volunteers. All right, let's see. Keen, why don't you come up here? No? Who wants to? Kim wants to? Okay, Kim, you can come on up here. All right, anybody in the back? Is that Shay? Shay, you're our lucky person, number 2. Why don't you come up on stage so everyone can see you? And then we're going to let you choose. And do you have 2 microphones? Great. We'll give a microphone to each of these fine persons. Yes. It is really bright up here, so maybe you'll choose to not be on the stage. All right, so we're going to do a little bit of surveillance with me. And one of you gets to sit down in the audience, and one of you gets to stay on stage with me. Discuss amongst yourselves. Oh my gosh. All right. So I would like for you to sit. Let's go with right here. That's not too far. Okay. All right, here we go. We're going to use some of our sensors. We're going to determine, with your sense of smell, if I showered this morning. Ready, set?
Okay.
And?
Go.
Can you tell?
I don't really smell anything, so sure.
Yes. How about you?
Did I shower?
No, if I showered this morning. I'm not asking you if you showered this morning.
I'll say yeah.
With your sense of smell.
I can't.
You're doing your surveillance from there, remember?
Yeah.
Okay.
I can't really.
You can't really tell. All right. Let's do sense of touch. Can you tell where I am on the stage with your sense of touch?
Yes.
Let's see it.
You are here.
And? All right. And then we're not going to do the taste, because no way, you guys. But,
Nope.
but I want you to understand that there is a reason why audio and video surveillance things are used more frequently than other things. It's because it's a human experience, and it's because the range of those things is so much better. Maybe when you were a baby, you went around tasting things all the time, but you don't do that often anymore. It's basically food and drinks, right? Somebody had a question over here. Yes? Go ahead. Okay, there's not a speed of touch or taste or smell. There might be. I don't know. I mean, I haven't done a ton of research into that, so I'm unprepared to answer any questions on that today. All right, ladies, thank you very much for your participation in this activity. See me after the program for your reward. All right, so now that we've talked about the human senses and the human experience, let's talk about machines and computers and robots and what kinds of things they can do that we can teach them. So we talked a little bit about the capacity for using our senses, and some of the things that we use our senses for, we don't have the range that we can teach other things to do. I know we've seen a service animal around the property here. Some dogs have incredible senses that we don't, and we can get machines to go in a much wider range than even animals can. In this picture, we've got a picture of an ultrasound device used for medical things commonly, and that device can detect things that you with your ears and your hearing capacity cannot. There's a certain range of frequency that you can hear, and outside of that frequency, you got nothing. You do not have the physical capability to listen to that without some sort of machine doing that. And then inside of your inner ear, you have balance receptors and a cochlea that help to keep you standing up straight. I think I'm doing okay right now, although who knows? Maybe I should have brought a drink or something if I get nervous. Inside of your cell phone, how many of you have an accelerometer or know that you have an accelerometer? That's just about everybody, okay? The sensitivity on that accelerometer is probably a little bit more fine than the one inside your head that makes you get a little bit car sick when you're moving very quickly and your vision says, oh my gosh, I think I'm poisoned, right? So those kinds of sensors expand the capabilities of what we have learned from the human experience into additional surveillance capabilities. Then we want to get into things that humans don't sense, right? How many of you can sense the radio waves emanating through this room right now? I hope not. Okay. Yes. I'm glad that you can see the EMR. That's great. But the radio waves themselves are at a frequency that we don't, as humans, generally interact with unless it's damaging, right? Unless it's causing serious tissue damage. There's also microwaves, different frequency band, but unless it's causing tissue damage, it's generally imperceptible. And then we have other things that extend maybe distance for things. We talked about the difference between the senses, whether you can sense it right here or down there, and how sound is so much better. Well, sometimes sound is better when you can get even farther away. How many of you have seen some of these parabolic microphones? Okay. For the research for this, I got into some crazy videos on bird watching and people building their own parabolic microphones. There's a whole world out there for you to explore, and it is fantastic. Pure entertainment. Highly recommend it. But if you're interested in those kinds of things, it might interest you to know what kinds of limitations exist for that, right? So in this case, this is a commercially available parabolic microphone, but it has a certain directionality and range, and you also need to identify what kinds of limitations that has for your application. If I want to hear the people in the back without a microphone, they could probably just yell, but if we had a parabolic microphone, we might be able to get a specific person, depending on the range, or it might get a lot of other interference, and we might have to figure it out later. And then, of course, drones. How many of you have drones? A lot of you. They're super easy to come by, very commercially available. How many of you do drone surveillance? Someone's honest, okay. When we talk about surveillance from things like drones, if you're hundreds of feet up in the air, and it's not very loud, it can be imperceptible, right? We also talked about the limitations of human capacity. With a lot of other things going on, and your hearing or eyesight the way that it is, you might not be able to see or hear something that can see and hear you. We also have vision extensions. Many of you have probably seen a telephoto lens, like the one in this picture, or perhaps have extended lenses on your cell phone where you can take pictures from pretty far away, maybe farther than you can see, in much greater detail. And then, of course, there's the software correction that you can add on top of that. How many of you have seen these sorts of surveillance devices in practice? Can you tell us what you've seen? Okay, telephoto lenses at conferences, or at concerts, bleh, sorry, at concerts to spot certain people. Okay. Okay, for suspicious activities, which could have some positive impact, right? It might make the concert a better place for other attendees. Other things that you've seen this. Spotting scopes. Okay, yeah. Personal security forces using spotting scopes. And maybe there's, a military application too, of course. And then, like I said, bird watching. Oh my goodness, those people, they get range. They know how to do that stuff. So if you want to learn long-range surveillance, make friends with bird watchers. All right, so let's break it down to a little bit of the foundation for all of these things. What are the properties of the things that we use for surveillance? When we talk about seeing things or hearing things, we're talking about sound waves and light waves, right? So what are the properties of those things that either help us to have surveillance or take away surveillance? What do you know? Yes. Distance. For example, okay, something that is farther away is harder to see or hear. Why? The waves dissipate, right? They break up. Yes. Yeah, so perhaps interference or harmonic frequencies and things that collide with each other. How many of you have been, it's probably been a while, but have had the experience of you're listening to a radio station and suddenly you get a different radio station? Maybe it's been a while, like digital radio sort of fixes that a little bit, but yeah, that's a negative experience, and from a surveillance perspective, that's a challenge. Yes. Yeah, too much reverb on an audio echo can cancel it out. Yeah, how many of you are hearing that in the back right now? Just kidding. If it's echoing itself out, you probably can't. What's that? A day-night cycle. Tell me more. Right, okay. Yeah. So sort of the physical design of cameras limits their capabilities, whether it's bright outside with daylight or dark at night. Additionally, the surrounding lighting has the opposite effect when it's too bright daylight. I don't know how many of you were were here. There was a conference here in Utah, not SAINTCON, a number of years ago that SAINTCON helped out, and they tried to project content on a projector screen. How's that? There we go. In the middle of the day, with giant windows on the side competing with the sunlight. And you don't have to be there to know what that's going to be like, right? You understand that the screen's going to be washed out and very difficult to see because, my goodness, how do you compete with the sun for light? That thing is gigantic bright all the time. So, yeah, absolutely. What are the ranges of those things? And this gets back to the same sort of range limitations that we have with the human experience, right? There are certain things that you can see and certain things that you cannot. How many of you wanted to go out and see here in Utah the aurora that was present within the past month? How many of you tried that? How many of you saw it without a camera? Maybe? It's a lot better with a camera, right? It's a totally different experience without it. Yeah, so there are those limitations, and some of that has to do with ambient kinds of things, like the sunlight or the lack of sunlight, and some of that has to do with the sensitivities that you have. Human eyes are not fantastic in the dark. There are lots of other creatures that are much better at it, and lots of other camera devices that are much better at it. But once again, not just any camera is better than any human eye. They're sort of designed for a particular purpose. Other things that you know about the properties of sound and light that help you understand this? Anybody? Yeah. Yeah. I don't know about you, but I don't have any thermal sensors built into my body. So that's really hard for me to see. Infrared, I'm not capable of seeing just because of the classification of my eyes as human. Colors, I'm pretty good at. Dark, sometimes. I don't know. Like, I'm still human. All right. Let's talk about obstacles. What are the obstacles for the visual and auditory surveillance? What things get in the way? Walls. Yeah, why? Will they work? Well, because the waves of sound travel through a particular medium. When that medium changes, it changes the transmission properties, and often when something goes through the air and it meets a wall, the property change reflects that sound back, which is why we can hear really well in this room what I'm saying and what you are saying, but we can't really hear what's happening over on the other side. And to be fair, let's be very grateful that the conference center has put together some incredible barriers here that are intended to block the sound. This isn't just a curtain, right? There's a difference here. And so there is a difference between the properties of those boundaries and obstacles that impacts that. Other things that you know about that are obstacles. Yes. Okay. Yeah, so color ranges for cameras can be an obstacle. And it could work both in favor and to detract from surveillance, right? You could get a camera that has much better color vision than the human eye, or you could get one that has much worse. And maybe some of you who have those doorbell cams have that. That's probably more likely just because it's so ubiquitous and commercially available. It's easy to produce a not very good camera. It's expensive and difficult to produce a very, very good camera. Yes? distortion through the material that it hits. For example, water, maybe for light, it's not necessarily just a reflective medium, although there is some light that's reflected, but some of it is also bent and refracted, and it changes what that looks like. Yeah. Other ideas? Can't see anybody back there. Yell out if I'm missing you. All right. We talked a little bit about range, and I want to make sure that we get to this. It's not just auditory and visual surveillance that has range. The radio wave surveillance and microwave surveillance and Bluetooth and Wi-Fi and all those things also have a specific range associated with them. And depending on the observation device that you use, whether it's a parabolic microphone or a specific antenna, I think we have some cool antennas around here somewhere, you can change the available range that you can use for surveillance. And you can also change the material that you're using or the method that you're receiving that. There are lots of different types of microphones, lots of different types of cameras, and we talked about some of them here. Most of the cameras that we have today are of a relatively similar design, and the implementation gets you different ranges. Microphones come in a lot of different varieties, and when we talk about things like what happens if you're trying to do surveillance underwater, well, that takes a different kind of microphone. How many of you have used an action camera and you've used it both in and out of the water in the same video? Yeah, what's that experience like? Rough? Yeah, it changes things. And so understanding the application for surveillance lets you know that there will be some difference in that kind of thing. All right, so let's talk a little bit about what surveillance devices are like today. What surveillance devices have you seen that you think are innovative for today? We're all carrying one. Perhaps it's on all the time. Yeah, okay. Yes. Yeah. AI can help replace some of the manual human review. Absolutely. Yes. Tell me more about license plate readers. Yeah, it can just process every time you go to a stoplight or something. And there, once again, like for surveillance, there are good and bad things to this. And I don't want you to get the impression that I'm saying, like, go hide in a hole and never interact with the rest of society ever again. You likely will drive a car again, and you will probably encounter some of these things. And there are, I think, strongly beneficial implications and applications of this technology and of surveillance in society. I mean, we saw a car accident out here just last night on the corner, and having that kind of surveillance would probably be really helpful for identifying how to resolve that situation. However, not all those things are necessarily as beneficial as our society would like, and maybe the motivations for the people who are doing that are perhaps in question. Yes? Traffic control sensors of what traffic? Like automobile traffic? Okay, yeah. So how many of you have had that experience where you're sitting at a stoplight and that traffic control device doesn't trigger and you're there for a while, right? Sometimes you want the surveillance to be better. All right, other ideas? Shopping, tell me about it. Yeah. Can you just pick up the items and you scan your card on the way in and walk out with the stuff that you need and hopefully gets it right? Yes. Tell me more about facial recognition you can't opt out of. Okay. So for the context of today's talk, it's very difficult for me to address like the Facebook and scraping content, but we should probably talk later. How many of you have a knowledge of devices that you have seen in practical use where they could be misused for surveillance? What have you seen? Okay. So maybe credit card fraud could be there. Yes. Okay. Yeah, so connecting surveillance up to perhaps some other database. There we go. Maybe. All right. How many of you have seen some of the perhaps more easy commercially available devices? For example, how many of you have seen, well, actually, maybe we should talk about this. My slide's up. There we go. I would suggest to you that modern surveillance that you should care about for your security is not like in the movies or in TV shows. Surveillance that you should be worried about might be more like a device that gets plugged in some place where you will be, and it is a USB charging block that has either audio or video surveillance built in. How many of you have seen those things? How many of you have seen them in the wild? How would that make you feel if you found that in your home or place of business? Very upset. I think it's worth understanding how those things work, because with the advances in technology that we continue to see, they are getting smaller and smaller in form factor, and they continue to be internet connected, so they don't have to have a lot of other things, right? It's as simple as a tiny little block that you plug into a power outlet. And they're often things that end up looking innocuous. How many of you have seen the stories of, say, smoke detectors or carbon monoxide detectors that have surveillance in them? So let's talk a little bit more about the detection of these things, right? Ultimately, the journey that we're on today is to understand how these things operate, and from a threat model perspective, which things you want to be most concerned about, and then we want to turn that into what are the actions that you can take individually to identify and perhaps remove or at least have a conversation with someone about that kind of surveillance. So what do we do to find these things? And I would suggest to you that the number one thing that you should use is your own observation. The power of surveillance that you have personally with the human senses that you have is incredible. So, what are some things that you know of that you can do to detect to see if there's surveillance in your surroundings? What are the things that you've been taught, that you've read online, that you've heard about? Yes? Okay, so you can put LEDs inside of a toilet paper roll and look around for pinhole lenses. And that helps with just the reflection off the glass? Okay, and it can reflect no matter where you are from the lens. Okay. Did you have a... A what? A phone flashlight. Yeah. And additionally, when we talk about, we talked earlier about being able to see the aurora, your phone can see things that you perhaps cannot. Infrared is one of those things. How many of you have taken a TV remote and pointed it at your phone camera and you see something that you can't normally see, right? It can see infrared where you cannot. That's super cool, but that also means that if you're looking in a room for an infrared camera, your phone camera can see it and your eyes can't. So that might be a little bit of an extension of using some tools for your power of observation. What other things should you be looking for? Yes? Okay, tell me about coil whine that a high-pitched sound that a power adapter might make. Okay, so maybe detecting a lower quality electronic device could indicate that there might be some added components into it. Okay, yes. Keeping inventory of your electronic devices, man, memorization and knowing what you have. How many of you, as part of your job, do inventory of software or hardware? Raise your hand. I better see a lot of hands raised here. That's super important. It's also important for surveillance. That is a great call out. Thank you. All right. Other things. Yeah, absolutely. Something as simple as I see this cord plugged in the wall and I don't know where it goes or where it came from. Yeah, absolutely. Yeah, some level of situational awareness. Absolutely. How about anybody in the back? Any cool things you've noticed or learned? Yeah. So using online databases, hopefully open ones that you have access to identify Wi-Fi networks that maybe don't belong or that you don't have. That might be a little bit difficult based on where you live. If you live in a place that has a lot of turnover for people, maybe high density housing, you might have people moving in and out a lot, and you might see a lot of those things changing. But yeah, your tooling can help with that for sure. Thank you. Is that another one? Over here, yeah. Yeah. So understanding how your devices work can certainly be part of that. Absolutely. I think we sort of merged into the discussion about machines and augmented capabilities, but I do want to talk about power. From a surveillance perspective, when we add in a machine component, it's not just someone who's watching you, it's something who's watching you or observing you. All of those electronics require power. And this is why it's as simple as looking at that thing and saying, what's that plugged in there? Is it plugged into a power outlet? Is it plugged into a smoke detector? Is it plugged into a power block? How is it getting power? Because most of the surveillance devices today are really good at just about everything but producing their own power. That's very difficult to create out of nothing. And so they generally tend to rely on power sources, and any surveillance that is long-term surveillance, battery is not an option. All right, so we talked a little bit about the tools that you have, and some of the tools that you have are built into your body. From a sensory perspective, you can reach out and touch that thing, pull the plug, and investigate where does that cord go. From the perspective of more advanced tooling, you can go all the way into getting frequency and spectrum analyzers to identify where wireless signals are emanating in your surroundings. Depending on your level, from a threat modeling perspective, you should choose for yourself which of those options is best for you. It also might matter which sort of threats you expect to be facing, because if you're concerned about a potential GPS tracker, most of the things that you can buy commercially available to detect GPS trackers actually don't detect GPS at all. They detect magnetism, and they detect magnetism from a Gauss monitor perspective to identify if something has been magnetized and stuck to your car. So if you find a device that's like that, you use that to identify, hey, is there something stuck to my car? Not, hey, is something getting some GPS coordinates on me? And that doesn't do anything for a device that's plugged into your wall and emanating Wi-Fi signals or Bluetooth signals or something of that nature. Does that make sense? And so ultimately, what I want you to understand is, as you're trying to identify how do I keep my space the way that I would like it, your threat modeling is going to teach you which things are important to you, which things you're likely to encounter, and that will inform what tools you need and what sorts of parameters you want to establish with yourself as a policy to address the concerns that you might have. And then there's some other devices there. So we talked a little bit about threat modeling. I can't stress that enough. If you want to understand surveillance in your life, you need to understand who's going to be doing this. Why are they motivated to do it? And what kinds of things are they likely to implement in my situation? All right, so let's close up story time because we're almost done here. In the story of the TV, it turns out that that's just an IR receiver. Maybe not such a big deal. However, IR receivers receive infrared light. Could you potentially use an infrared receiver to create an image of a thing? Yes, an infrared receiver can also be a camera that's an infrared camera. That's what an infrared receiver is. So all that transmission can be recorded. Things that you can do about that? Well, just like the camera on your laptop, you can put a piece of tape over the top of that or put something in the way, and that obstacle eliminates that surveillance possibility. And in this case, this is a fabulous infrared sauna to help us understand that infrared is a thing that we don't see. However, just because you don't see it doesn't mean the surveillance isn't there. In fact, often that's the purpose, right? That's what they're trying to do. Now, going back to the story about the plug, plugged into the wall, curled up and down and back into the wall. I searched all over and could not find the other end of that cable. What do you do when there's something plugged in a place where you are staying and you don't know where it goes or what it does? My answer was very simply, unplug it. No one came to tell me, hey, you broke the rental agreement because you unplugged the furnace or something. And so it worked out well for me. I don't know if that's the right answer for everyone in every situation, and this is why the threat modeling is so important. However, that's what I chose, and I believe that it worked out for me. All right, so can you do this? Can you do some modeling for yourself, identify what potential surveillance threats you might have, and can you take action to fix that? The answer, of course, is yes, you can. You do it all the time. It might take some practice to get very good at it, but you detect these kinds of things all the time. You probably notice the cameras walking in this facility. You've seen those. You know that they're there. Knowing that they're there lets you make the choice of what you want to do. That's all that I have for you today. I hope that you can go out and take what you've learned and turn it into something that helps you in your life, that helps protect you, your family, your enterprises, the organizations that you represent. If you have any questions, I'll take them now. Okay, if you don't have questions or you want individual questions, I'll be over here. And for those of you who helped me out today, you can see me after, and I've got some cool prizes for you. Thank you. Hi there.
Thanks.
You're welcome.
I'm Ethan. Nice to meet you. You said your name's Seth, right?
Yes.
Where do I find other talks you put together about privacy online stuff?
There are some that are recorded as part of SAINTCON. Unfortunately, the one that I usually give is actually a privacy workshop, and in the past we never recorded work. I think we still don't actually, but I'm happy to talk for a minute about it if you like. I mean, maybe not. We'll answer some other questions.
Yeah.
You already have all my mini badges, right?
Is that the prize?
It is.
Okay.
I have a board extender for you though.
Okay.
A clip-on.
Call them clip-on.
Oh, I got to turn that off, don't I?
So this will go maybe that. Oh, sorry. It'll go exactly like this behind you. Okay. Cool. Shaped weird. Doesn't make sense. Somehow. Oh, that goes on the back of your head. Sorry.
Oh.
Oh yeah. Very good. There you go.
Awesome. That makes a little more sense.
Yep.
That work?
Yep.
Cool.
Just on the back of you.
Nice. Sweet.
Yep. Now it'll be on the back of you. That way you have the wire behind you.
These are fun.
Now you both look like Britney Spears instead of just me. I like this.
It's quite the boom they got on the front of that.
I think I have a giant head. I think yours is off.
Just flip the switch on the top right here.
So I thought I had it on for you.
Nice.
Oh god. I opened my camera and it was a selfie mode and I wasn't ready for it.
Whoa.
All right.
Check.
Let's get one. There we go.
Get the SAINTCON in there.
Good. Too much glare. We'll get one from over there.
All right. Cool. I leave my stuff over here. No.
Let's go over here. Thank you.
Yeah.
Yeah, I do. And does this come on, like, so I can test it out? Test, test. Test, test. Perfect.
Check, check. You have the power cord?
Yeah, I got it right here.
Power cord goes right here.
Oh, you got it?
Well, I mean, that's just where it goes over here.
Trying to find an outlet.
Here, right here.
Oh, nice.
Yep.
This does feel like Britney Spears up here.
Ha. Where's our mouse?
There it is.
Cool.
Cool.
Hold on. Why is this not working?
Is it on?
Yep.
There it is. Nice.
Well, I wish that monitor was over there, or maybe you can get that over here. Does this TV work at all? Looks like maybe I just got switched up. The clock's off too, so I wonder if the power outlet got. Oh, it's blinking 12 now. Hey, that'll be better. Then we don't have to huddle up over there.
Yeah. That work okay for you?
Yeah.
Nice.
Good. Do you want to run the clicker?
I don't know, in case you wanted to.
All right. It's fine. What's that? That's totally good.
That way I don't skip over something you have to tell me to go back.
No, that's good.
All right. This is exciting.
Yeah, I think so. I think people are still filing in, but. Hello. Welcome, everyone, to Vendor Vortex, uncovering hidden threats in third-party software. My name is Tom Pohl. I'm the principal consultant at LMG Security, as well as the penetration testing team manager. LMG Security is a cybersecurity company out of Missoula, Montana. And with me today, I've also got Derek Rowe.
Hello, everyone. I'm penetration tester over at LMG Security as well. One of my main focuses are going after vulnerabilities, identifying them in different types of software. And including in that is third-party vendor software. And, well, just to spoil it, we're going to show you a few examples today of that.
But before we get started, I want to make this talk very interactive. I love, when we have, back and forth dialogue with the audience. And so if you have a good question, we only have a few left, I think 4. But if you ask a good, interrupt me anytime, interrupt us to ask a good question, we've got shot glasses we'll throw at you. So I encourage you guys, I want this to be a discussion, a dialogue. I love the back and forth because, some of this stuff is scary and you'll see it on your networks and you want help. And we're here to help and talk about it today. So anyways, good questions lead to good shot classes. So let's get going. In every one of your white bags that you got, you have a card with a key on it. And that key might unlock a treasure chest down at our booth downstairs. I know we're giving away, every key that unlocks the thing, we're giving away a drone. And I think we've still got one left to give away. So, did they give them all away? I don't think so. There's one left. Yeah, Matt says there's still one left. So if you haven't checked your key at our booth, the chances are pretty high at this point that you might have won a drone. So go ahead and go down there and do that later. Anyways, so why are third-party vendor vulnerabilities important, right? Often we're running lots of software that we didn't create on our infrastructure, on our networks, and they can be opening up vulnerabilities that can compromise our organization. And often we're installing software that we just blindly trust, right? And maybe they'll come out with a patch or so forth, but we should really look at our software that we're installing critically with a critical eye and say, gosh, do we really need that? Do we really need to do this thing? Or do they even realize that installing a piece of software actually exposes things that the vendor may not even tell you that they're exposing? And so we're going to show you 4 real-world examples of vendor vulnerabilities and what we've seen in the wild. And so these aren't like, hey, maybe this is a thing. This is like what we see on our penetration tests with other organizations that are alarming and that we should all be worried about.
Yeah, absolutely. Thanks for going over that, Tom. So to begin, our first example, this is, so to start off, what our most important thing whenever we get ready to do an engagement is enumeration. Oftentimes, this is using Nmap so that we can discover what services, what ports, what versions are. And so that's what you're looking at here is we were able to actually see a Power Panel login interface can you hear me? Through our enumeration. And all we had to do is simply bring it up over our web browser, and that's what we're looking at here. Just to fill a little context on what this Power Panel really is, a UPS, it's essentially it's a device that's going to provide backup power to keep your electronics running if there happens to be any kind of power outages or any kind of business operations on the electrical front. So first thing we check whenever we find a login interface such as this is default credentials. And Tom, you probably can attest to this. Maybe once every engagement?
Yeah, every engagement, you're going to have something on your network that's probably got a default credential still, right? I see this in organizations all the time. Like maybe you've got you've got 6 printers. They're all configured exactly the same way. They all showed up with your lease at the same time. And then eventually they're like, oh wait, we need another one. And so you'll add a 7th printer, and it doesn't go through the same change management process as the first 6, right? And somebody forgot to change the default password on that one. We'll see this kind of a thing in organizations all the time, where they're trying to be diligent in managing things like a default credential, but you don't always get there, right? And so unless you're in your network testing these things, I would argue, especially with the new California laws, default credential is a vulnerability, right? It is no longer okay for a device to come from the manufacturer with a credential that you can literally Google and find the answer as to what the default login and password would be for a device. And so that's what we did here in this particular case was we Googled, hey, I don't think I've ever seen this product on a network. Usually it's like Schneider Electric or APC or something like that. Mm-hmm. And so it's like, what is the default credential for this particular device? And we found it. In just a Google search away, you don't even have to click on a link. You just Google, hey, what's the default password for this? And they're like, here you go.
Absolutely. And so we were able to use admin to be able to gain access to this interface. If you want to jump to the next slide here, perfect. And did you want to go over exactly what we're able to find once we gain access?
So once you get into the device, it's like, what is it that we have access to? And in this particular case, often with an uninterruptible power supply, sometimes you've got access to turn devices off. Sometimes you have information. So we'll often want to glean as much information out of these interfaces or take advantage of their positions in the network in order to gain more access to an organization. So typically when we get into something like this, it might have like, hey, it's going to send email alerts, right? So when the power goes out, it's going to try to let somebody know something's wrong. Or if there's a battery failure or whatever it is. So there might be credentials there in order to send email. There might be SNMP community strings so that we could gain more information by using those, trying to reuse those community strings on all the other network resources on the network. Whatever it is, we might try to elicit or even doing what's called a passback attack to get a credential from a device because to relay it over to us so we can gain access to a password. But in this particular case, it was a little bit easier than that, wasn't it?
Yeah, actually, essentially all we had to do is highlight this text on the password text box down here and right-click it to reveal password. So what we're looking at here is this is a vCenter login within the service infrastructure management settings. but somebody lost it along the way and forgot to go back and delete it because it was still saved there whenever we came through doing our test.
Yeah, so what's important is that like this device needed to be able to log into vCenter, right? So if the power went out, it could go log into vCenter, gracefully shut down all your virtual machines before the power ran out. And so it had credentials in the power panel, but the problem is that you shouldn't be able to get that credential out of the web interface, right? You know, most printer manufacturers have fixed this, but apparently CyberPower, yeah, that's what it was. CyberPower didn't do that. You could literally right-click reveal password, and now you've got a username and password to vCenter for vCenter operations.
Or so we thought.
Or so we thought. So we went ahead and tried those credentials out, and it turns out this must be an old, out-of-date piece of software because we couldn't actually use that username and password to log into the network or log into their vCenter, which is a good thing, but it was a really juicy password, right? So this looked like a password that should work somewhere because, you know, the way that this organization was set up, it just looked like, okay, where can we use this password elsewhere? So we actually went to their Active Directory domain controller, and we used a technique called anonymous SAM-RPC. So we went to the RPC service of the domain controller, and literally you pass it no username and no password and say, give me all the users. And it's surprising recently, you know, I'd say in the last 6 months, 40% of organizations that we've tested have anonymous SAM-RPC available, where you can just say, hey, give me all the users, and it'll literally give you every user. And you can not just get users. You can get users, you can get group enumeration, machines, you know, a lot of even password policies. So like if I want to do password spraying against your organization, I know how many tries I can get against your domain controller without locking out a user. And so, you know, using that information and using that password, we went ahead and did what's called a password spraying attack. So we basically, with that username list and this really juicy password, we went ahead and hit every user in the domain until we get success. And it looks like Jessica in this particular, all of our screenshots, by the way, are completely redacted. Sometimes you'll see that because these are real examples from real networks. We'll redact everything so you can't tell where this is from. It wasn't actually Jessica that was the user, but we had a user that used that same password on their network. And then actually that was a domain administrator password, right?
Yeah.
So then at that point we could you know take control of their entire network and access any resource on the entire organization that we wanted to.
Super incredible. Super
fun.
incredible. As
So
far
that
as
was example number one. Like literally, you know, I'd say there's actually two vulnerabilities there, right? One is one that you can mitigate, default credentials, right? The second one is one that the manufacturer has to fix, right? And so that's the, you know, you shouldn't be able to get a password out of a web interface for a management device. So
yeah,
yeah,
totally agree.
terrible things.
Terrible things. So moving on to our next one, we promise we're not just picking on Power Panel. But as you can see, this is a different Power Panel. This is Power Panel Enterprise, it looks like. So different version.
Different client.
Different client, yeah. Thank you. But once we enumerated this actually able to discover that it was vulnerable to CE 2023-3265, which was actually talked about. It was a talk during DEF CON
last year.
Last year, yeah.
Yep.
And so we were super excited to get to try this out and test drive that CVE and see if we could crack it open. Let's dive into that a little bit. What exactly is that vulnerability? The vulnerability that we were able to find on this, again, the CVE, is actually a hidden option labeled L, and you're able to actually see it once you open up the inspector tool, as you can see here. And just take a look and see the display none option. So we take a look at that, and we're following this, you know, proof of concept. What happens if we were to change that to something other than none? So essentially, that's what we did.
Yeah, we switched it to block, and all of a sudden, a login control pops up on the page, right? That has two options, right? System, local system, and LDAP. And so it's amazing, right?
Yeah.
All you got to do is choose LDAP, hit the login button. Guess what happens? You logged in. You're admin now. You didn't even need a password, let alone a default password. So they didn't have a default credential there, but we didn't need a default credential. We just tricked the login page into thinking that we're trying to log into LDAP, and because LDAP wasn't actually configured on it, it let us bypass the entire authentication process, and now we're into the device as administrator. And again, what is it that we're going to try to do? First time we get into a device like this, we're going to try to get as much information out of it as we can. So we're looking for, opportunities to get other information. In this particular case, it didn't have much information in the interface, but what it did have was a way to back up the configuration. And so this is interesting, not because we could get a backup of the configuration, but because you can actually specify where do you want the backup to be stored. And often they'll be like, oh, you want to store it on the C drive or the D drive or wherever, or you can even put it on a UNC path to a network share. But one of the other vulnerabilities that excuse me, this thing's kind of flaking out. One of the other vulnerabilities that was discovered around the same time as this LDAP vulnerability was basically a command injection vulnerability. And so actually, I dug into their proof of concept, and their proof of concept didn't actually match up what we know worked with this particular web interface, because it was base64 encoding both username and password, but it wasn't base64 encoding the storage location. And so what I did was I captured the request to the server with burp sweep, and you can see here, I changed the storage location to put a single quote, space, and then a PowerShell command that then grabbed a PowerShell script from attacking server that I controlled and then executed. So download and execute. So IEXIWR. And then I grabbed tomshell.ps1. And what happens on the back end, if you look at the source code, is that it's stringing all these variables together and then running it as a command on the system, which is terrible. Is anybody here familiar with SQL injection? How does SQL injection work, right? You're stringing strings together, you're doing a query against the database. This is just like that, except you're stringing strings together and then you're executing as a command. And so what I did was I terminated one command, ran my own command, and then allowed it to continue on with whatever it is it was trying to do. So I injected my own command into the middle of this execution process. And what does that give me? It gives me a reverse shell. And so what a reverse shell is basically this PowerShell script downloaded a program and then opened up a command prompt that let me remotely control the command prompt. And so, so my first rule of thumb is like, let's create a local administrator account, because who is this running as? It's actually running as NT authority system. So it's local admin of the host. And so one of the things that we like to do if we get a local system access onto a box is let's create our own local administrator account. So we created our own, and these are the commands here that we ran, were to create our own LMG admin account and then add that local admin account into the local administrators group. And what do we do that for is because so then we can connect to that box remotely using some of our own tools. And so we use a tool pretty extensively called NetExec. It used to be CME or CrackMapExec, but that's been kind of abandoned, and now NetExec is the new hotness. And actually, it's a pretty fantastic Swiss Army knife tool. So if you're in penetration testing and you don't know about NetExec, run, don't walk, go find out. But what we could do is we could dump both the SAM and LSA registry hives. Do you want to talk about that?
Absolutely. So this is normally where we start getting with what we can do to pivot off of this box. So we got admin permissions locally to this box. What can we find hidden in here? When we're dumping SAM, and when I say SAM, LSA, these are going to be registry hives that store credentials within memory. Sometimes EDR will come after us, and we'll talk about what we can do to prevent that. But while we're doing this, when we're dumping SAM, we are trying to get all the NTLM hashes of all the local users on there. If we have an NTLM hash, we can pass it just as if it was a clear text password. And so what we'll go ahead and do, we'll see that we have an administrator NTLM hash here. We'll also see that we're dumping LSA, which is going to be more on the domain as far as credentials that are saved within that memory. And so we find a variety of different hashes this way through dumping LSA. We also find clear text credentials sometimes, which is amazing, especially when it's a domain admin. And so what we'll go ahead and use for this example, though, is, and we're keying in on that administrator NTLM hash that we dumped out of SAM, is we'll start performing an attack, like I mentioned earlier, past the hash. And what we want to do with this is we want to see if there's any password reuse when it comes to local admins on any of the other systems that are on the network. If we're able to get local admin to any of those, then it's just another opportunity to dump more passwords, more SAM dumping, more LSA dumping, and potentially lead us to the promised land of getting DA one day. And so as you can see here, we were able to get a few of our systems that, if you see pwned on the right, and if you're a penetration tester, it's when you see that, you just get that super excited feeling inside you. Pwned means that you have that local admin permission, and so you can start performing those dumps of the stored credentials within memory. Let's see, moving on. Oh, this is your part.
Yeah, so in this particular organization, they're running an EDR that would block a lot of things. So we could actually do an authentication against it, but outside of that power panel example, we actually couldn't dump LSA and SAM because of their EDR was blocking us. And so I've got just a whole tool bag of bypasses depending on what kind of EDR they've got. One that works on a lot of EDR products is if you either over like AT exec or WMI exec run Microsoft Bless tools that are built into Windows, you can often execute those remotely and not get blocked. And often you don't even get an alert on it. And so one of my favorite go-tos is if you're connecting to a server that is running Internet Information Service or a web server running web applications, they will often have app pools configured that with credentials. And so I'll run a tool called App CMD where you can actually list the configuration of the app pool into of each application pool that's configured on that host. And so if you hit every host that's running that with this app command, you can actually dump out clear text credentials. And what happens is a web application in your environment may often need to run with a specific level of permissions in order to access other resources on the network. And so you'll configure typically a service account into those app pools, and that service account only be able to do the things that it needs to do, but often we find, with a lot of organizations, they're configured way more than what they need to do. And I'd say I'd even hazard a guess that probably 25 to 30% of the time, these credentials are domain administrator, because you're like, oh, the domain administrator has access to that database. Let's just put that into the app pool. And so when we were able to dump that, we're now domain administrator. But in this case, this isn't what we did, is it? Because it didn't actually, we got some more credentials, but it didn't give us any more access in this organization than what we had already had by dumping machine, LSA on that first box. So that LSA got us a machine account. This got us some low-level user credential that was actually limited. So what did we do next, Derek?
I think we turn our target to something else, and certificate authority. I know you and Matt's talk was just a little bit earlier and super interesting. That would normally be our next step, is to turn our target towards that.
Yeah, so in a lot of organizations nowadays, especially with hopefully NTLM is going away, right? You're switching to other authentication mechanisms, going to more PKI-based, Kerberos, and so forth. And we'll find often organizations are implementing PKI by implementing Microsoft Active Directory certificate services. And what this is basically a mechanism for managing your PKI infrastructure into your organization. And why are they important? The CA is super important because it's like a principal that issues hall passes. Right, so once you are given a certificate or allocated a certificate, you can use that certificate in the way that it's been allocated to be used in your organization. And the one that we want to hone in on today is authentication, right? So it's super important that if you're getting certificates issued by your certificate authority internally, if it's being issued with client authentication, you need to make sure that it's working appropriately, because if you get a certificate, we'll go through some of this in a little bit, but often your certificate authority, you can get access to other resources that they didn't intend, your organization doesn't intend to give access to. So first of all, let's set this up. So what we're going to do here is called an NTLM relay. And so we should probably take a step back and understand, we keep talking about this thing at NTLM. And so there's NTLM hashes, which are basically password hashes that can be used directly in logging into other network resources. And then there's an NTLM v2 handshake, where basically when one network resource wants to authenticate against another network resource, it does a dance where basically, hey, it says, hey, I want to talk to you, I want to authenticate against you, and I'm like, cool, here's a challenge. So I give you back a challenge, and you have to hash your password and the challenge and hash those together, and then give me back the response. And I don't know your password, but I do know your password hash. And so we can do this little dance on the network and never pass the password across the network, but we can prove that you have the right password, I have the right password, and we can agree that we can log in and talk to each other. And so we're going to use a technique here called pettipotum. And so pettipotum is a vulnerability that was released in 2021, where it's a coercion technique where unauthenticated a user, a non-authenticated user could initiate, make a domain controller initiate this NTLM v2 handshake with me or with an attacker in order to relay that onto another resource. Whereas that's patched, what happens is that even if you're patched for pettipotum, there's a second version of pettipotum that's an authenticated-based pettipotum, where if I can log in with a domain account, like we've got a couple now, right? We've got that app pool password. We also have the machine account from the power panel. We can actually use that credential to log into the domain controller to elicit that domain controller to connect back to us, and we can use that authentication to relay it onto another service in order to gain more access into this organization. And so this is our example of we connect to the domain controller, get it to authenticate against us, and then we relay that on. And in this case, so we're using a tool called NTLM Relay X. So this is a tool that that is designed to do this three-way handshake or this handshake with the service. But what happens is when you connect to me and say, hey, I want to authenticate against you, I don't actually want to do that authentication. I want to authenticate against another service. So in this particular case, it's the Active Directory certificate authority. And so what I'll do, you connect to me and I connect to it, and it's like, okay, here's the challenge that you need to authenticate against. And so I send that back to you. You do the hashing against it. You send that challenge response back. I send it over there, and certificate authority says, cool, you could get a certificate, because every Active Directory certificate services has templates, and typically the Active Directory, the domain controller authentication template is enabled by default, and it's not vulnerable to anything, but the issue is that since you say you've got either the web enrollment or RPC enrollment enabled with an escalation vulnerability, 8 or 11, I can now get the certificate of the domain controller just because you have Active Directory services web enrollment enabled. And so that's what we did in this particular case is we used that low-level credential to get a domain controller to talk to us, and then we get the certificate of the domain controller that then we can use to escalate our privileges in your organization. And so, the way that it works is once the certificate is issued, we can actually do an authentication with a tool called Certify, where we give Certify this PFX file, this certificate that we were issued, and get the NTLM hash. And so that, like I said, that NTLM hash is just as good as the password when you're inside of an organization. And so once we have that NTLM hash, then we can actually use another tool called Secrets Dump. Go to the domain controller and say, hey, domain controller, I'm your buddy domain controller. I'm this other domain controller over here. I want to synchronize all the password hashes with you. And it will dutifully give you all the passwords for all the accounts in the domain, including domain administrators at that point. Yep. So that was the end of example number 2. Yep. So we went literally from access to a vulnerability in a power panel to then take that all the way through to dumping all the domain credentials in your entire environment. So that's bad, but it gets worse. Just wait. That's not all. The next example we've got was a credent login, the Mobile Guardian Shield. I'm not exactly sure what this thing is. I don't know if it was a mobile device management of some sort, but it was some kind of software that was installed on this client network that when we scanned the host, it was running a web service for whatever this credent tool was, but it also had a Java remote method invocation port open, so port 1099. So basically what RMI is it's a Java component to a web application server that if you're running it and allowing it on the network, it can be by default or misconfigured where I can, as an attacker, gain access to run code that's already running, that's already on your server. And so in this particular case, we enumerated everything in the RMI interface. We found several vulnerabilities. And so once we find that this is a vulnerable RMI interface, we can start wanting to run our own, or not our own code, but code that's already running on the server. And so we figured out that this credent web application was actually a Spring-based web application. Anybody in here do any Java development or know much about Java web applications? Spring is a framework that a lot of applications are written in, and so whereas your developers could develop everything from the ground up, they'll often use a web framework to make creating the web application quicker and easier to use. And so in this particular case, since we discovered it was running a Spring-based web application, we used a tool called WISO Serial, which is basically a gadget interface that basically says, okay, if you're running this kind of a framework, if you're like Spring framework on the application, I know what I can send to the classes to run whatever program you want. Or say you're running Commons collections, or it actually has just a giant catalog of, if you're running these Java classes, it knows how to basically run whatever command you want by using those classes that are already loaded on the system to run the commands that we want to run. And so in our particular case here, it was pretty blind. And in fact, the first thing that I did was to test out proof of concept was I said, okay, ping my attacker IP. And so I ran Wireshark or TCP dump, and I said, just look for ICMP from this host. And when I said, okay, ping my IP, I got pings back, which means I knew I had remote code execution on the box. And once you have remote code execution, then you can do anything that service can do as the user it's running as. And often these applications are run as a local administrator or some kind of an administrative privilege. So in this particular case, blindly, we ran that, did like what we did before. We were like, let's create a local administrator account. So we created a local administrator account. We added it to the local administrators group. We didn't actually know, we didn't get any feedback to know if this worked. So then we used our trusty NXC tool, and we logged in with that LMG account, and at the bottom you'll see that pwned again, which means not only did that code execute, but it had the permission in order to be able to add a local account to that system. So once we added that local account to the system, then we went back to our typical technique, right? So remotely we'll dump the SAM, we'll dump the LSA, but this time in LSA, there was a service that was running on the box that used a domain administrator account. So actually at this point, it was like game over. We had direct domain administrator access because the service account or a service on that machine was being run as a domain administrator account. And that was a game over for yet again.
Absolutely. Scary. But not as scary as this next one coming up.
Yeah, so
this is the worst.
So this frustrates me a lot. So who's watching the watcher, right? And the reason why this really frustrates me is because sometimes the security tools that we're installing to protect our networks are the vulnerability. In this particular case, we're on an organization's network, and we were scanning hosts, and we found this web interface that was a SecureWorks web interface. There's their enterprise agent for Windows. So it's actually a custom branded version of what's called Snare. And it was very clear to me, if you look in the upper right-hand corner, it's hard to see, but it's like your license expired in 2020 in August, right? We just did this test 8 months ago. So clearly this is software, and literally we scanned the entire network, and this is the only instance of this software that we found. So likely what happened is they were probably a SecureWorks customer. They are no longer a SecureWorks customer, and they uninstalled this web interface or this agent from every server or in every computer on their network, except they missed one. And so this is the server that they missed, and we found it. And by default, it's mainly a read-only interface, but it was unauthenticated. So literally, by having this installed on your network, it's actually a vulnerability, and I'm going to show you why. So this is the page that we're looking at right here is the heartbeat configuration, log configuration page. And you see here, there's an option for export the heartbeats to a file. And by default, that file is supposed to be C snare/heartbeat. And I said, well, what if it wasn't C:? What if it was my attacker IP, /snare? And so I literally was able, I checkmarked the box, I changed it to my attacking host, and I hit apply changes. You know what happened? I got an NTLM handshake. So that machine now, as the user that was running snare, would do that NTLM handshake to me that then I could relay on to another service. You want to tell them what service we relayed to?
Yeah, and honestly, this is one of my favorite ones. I feel like it's the most neglected when it comes to security controls. LDAP, that is the protocol that we're going after. And just to briefly go over LDAP, it's the Lightweight Directory Access Protocol. Think of this protocol as basically a virtual phone book for network resources that will essentially allow different applications to get information about verifying users from one central place. So it knows it has to go directly to LDAP, and LDAP will provide that information. Okay, so LDAP, it'll also contain usernames, passwords, other attributes commonly used for user authentication. So it's very juicy whenever you hit it right. Whenever you get in and you're able to authenticate to it, you can actually, we'll go ahead and show in the next slide, get an LDAP relay. With the LDAP relay, there's several things that you can do, but what we're wanting to do is kind of like what Tom was saying earlier. We want to relay that NTLM handshake over to LDAP so that we can make that connection and we can log into LDAP. Once we log into LDAP, we can do basically what a standard user account can do if they're able to log into LDAP. And just for fun, this is for a shot glass. Who knows what a standard user account can do, or maybe what we might want to do if we do get that interactive shell with LDAP and we're able to log in? What was that? Yes, that's one of them. We can enumerate information.
You get a shot glass. Who said that over there? Query the domain. Yeah, they enumerate the domain. What else can a regular user account do? Anybody know?
Yeah, I'll give you a hint. If you went to Tom and Matt's talk an hour ago, the answer was said. What was that?
No, it can create a computer account. So what happens is that a standard user can create a computer account, create a new object in the domain. Does anybody know by default how many computer accounts can be created? 10.
Perfect.
I saw 10. I saw 10 fingers right there. Here you go. I don't have a professional football. That's why I do computers, because I can't throw.
It's my favorite thing, watching Tom throw things.
Yeah, Derek's better. He should throw the things.
But absolutely right. So what we want to do is we want to create ourselves an account so that we can log in. We don't have to relay anything anymore. Now we can just log in with our own username and password. So we'll create our LMG machine account. And I think on the next slide, this is where you'll see the interactive shell. Now, we can't create this on just regular LDAP. We do have to upgrade it to LDAP-S, the secure encrypted version of LDAP. So that's where we'll see this command start TLS. That puts us authenticated to LDAP-S. And what I find really interesting, Tom, and you might be able to explain this even further, is if even you have the security controls set up on LDAP-S, which is binding, required, we can circumvent that by establishing a LDAP shell with just LDAP and then upgrading it through this technique.
Yeah, so if you don't have signing enabled on LDAP and you have channel binding, so we'll see this often where they may have one or the other and not both. I like to go to LDAP instead of LDAP-S because often it's been enabled because you've got some legacy piece of software that needs to talk LDAP. And often you're not talking LDAP-S, you're not doing SASL, you're not doing any of the advanced encryption techniques. For some reason, the thing that needs to talk to LDAP needs to talk unencrypted. And so often it's configured very weakly to enable any user to log in as LDAP, and then you can upgrade that to an encrypted version of the LDAP connection via the unencrypted port.
Absolutely. And so now we're able to authenticate to the domain. We have our machine account, we can authenticate, lots of things that we can do at this point. One thing being that we can start, I think it's on the next slide, we can start querying different templates that might be under the certificate authority. We can start looking for misconfigurations or vulnerabilities that we can continue to exploit through our attack chain. Right here you see Certify again. This is where we're actually dumping and enumerating the certificate templates. The certificate authorities may even be vulnerable. And so we're able to also see which ones are enabled so we don't waste our time on any that might have been disabled, you know. But essentially in this case, we were able to find a vulnerable instance of a certificate. And this was the fun one. This is probably one of the most straightforward one, I would say, escalation 1.
Yeah.
And this is just a little highlight of why it's vulnerable. And Tom, your talk, you spoke a little bit about this, but the enrollee being enabled enrollee subject, definitely part of that vulnerability with it being the misconfiguration that creates this as such a dangerous exploit. And all we need is just an authenticated user. So let's rewind real quick. We have an authenticated user because we just got done creating a machine account, right? So in my opinion, I think this exploit would work. And escalation 1 says any authenticated user can request a certificate for any other authenticated user. That sounds like maybe a good attack path to get to DA. I don't know.
It's pretty bad.
And so we go ahead and we push through this. We push through as far as dumping the domain admin NTLM password hash. And really, this is the only other command that we run in order to get this. It's a pretty straightforward exploit. We figure out exactly what the vulnerable template is. We provide that template name, and then we provide the subject.
Yeah, so when we enumerated LDAP, we know who the domain admins are, right? So we know who it is that we want to emulate. So we can see, okay, if we can go and assume the identity of any user we want, we know a user that's really important on your network. So we'll go and we'll emulate that, or we'll request a certificate for that domain administrator account, and then we'll be able to retrieve the NTLM hash because we'll be able to authenticate with that certificate and get that NTLM hash directly from the domain. And once we have that, we can then become the domain administrator without actually even knowing their password.
Oh, don't even have to waste time on that. We can just pass the hash just similar as we did in the past, and we can authenticate, and we'll get that fun little pwned right next to the DC.
That's right. And so then with that domain administrator hash, we can go to the domain controller and request to dump the ntds.dit directly from the domain controller, which gives us the NTLM hashes for every user in the organization. And we can take those password hashes, take them offline, we can crack them, we can authenticate as those users against other resources in the network and completely be able to take over your entire organization.
And sometimes this is really important information for our clients. Even though we just got done taking over their entire domain, that hurts. But now we can start putting all these NTLM password hashes into our cracker to see what weak passwords exist on their domain, which
exactly.
I've talked to a lot of clients that really valued that, just because they're able to find those those machine accounts that have, welcome 123 on them from 10, 15 years ago. They're able to zero in on that.
Yeah, we actually, one of our coworkers, Emily Gosney, is amazing. She actually used to run a company where they created the password crackers, and her team has won the password cracking at DEF CON for a decade now, every year. And within about 4 to 8 hours, we're typically successful at about cracking 80% of the passwords for most corporate networks that we test. And so it's kind of scary, right? So when we say, hey, you should have a 25-character password on your service accounts, we mean it, because these things can be cracked so easily nowadays with all the GPU powers. Now, especially with so many GPUs flooding the market for LLMs and everything else, password cracking is a way that once you get these hashes, you can get all the passwords, and you can do things like password stuffing attacks, right? How many of your users you think use the same password on the domain that they use on their Facebook account or their banking account or anything else? And so this is why helping your users understand password hygiene and using good, long, secure passwords is important. And that's it. I think we've come to the end of our talk. Are there any questions? Yeah. Yeah, so the domain controller is running LDAP. And so what we're doing is we're acting as a relay. So we'll use NTLM Relay X to listen on 445. So then when we get that NTLM connection to us, we actually do a protocol change. And so we'll then connect to the LDAP service to get its challenge and send that back. So we're actually facilitating a protocol change between SMB and LDAP, and then do that handshake. And then we actually, I love putting NTLM Relay X into an interactive shell so that you can do multiple things at one time. You can dump the domain information, you can try to create a computer account, you can even do some role-based access permission changes depending on who's connected to you. Sometimes we'll get a relay on a user account that's a domain admin, and then we'll be able to create our own domain admin directly. So it's so we're basically kind of jumping into that middle of that connection, and then once we have that authenticated LDAP session, our tool knows how to talk LDAP to do querying, how to create users, how to modify rights, and things like that. So I recommend always disable LDAP and on LDAP S, enable channel binding. So you can't do that man-in-the-middle attack. Yeah, right here. So the question is when we did this LDAP attack, did we do this externally? Did they allow SMB off the network? The answer is, it depends. We don't typically test that way. So when we do an internal penetration test of an organization, we typically, what we'll do is we'll send you a box or have you spin up a VM on your network in like a user segment, or plug in our box like into a conference room. And so then that machine will connect out to our infrastructure and allowing our users to pivot back into your organization and do this testing. But what Trent is getting at here is often what we will see is that organizations allow any traffic from an end user device out to the internet on any port you want. And so we'll send, if we do an external penetration test, we actually often send an email to users in the organization with a UNC path as an image file to see, will they do an NTLM handshake with us across the internet? And the answer often is yes. And in an external test, we'll get that NTLM v2 handshake, and we'll go and try to crack that offline and then see, hey, do they have a VPN exposed that now we have a username and password for, and then try to turn an external test essentially into an internal test if we can authenticate against their VPN server. Any other questions? Well, thank you so much for, oh yeah, right here. Is that a question? All right, sorry. Thank you so much for your time today. Yeah, go ahead. So the first CyberPower, not fixed. Second CyberPower was fixed. Our client didn't have a patch for it. And it was, like I said, it was within a 1-year-old patch. So how often you patch your Internet of Things infrastructure, and that's what they were vulnerable to. Is that it's like you're patching your Windows hosts, right? You're patching the things that have automatic patching, but things like Your printers often don't have automatic patching. Your apparently CyberPower doesn't have automatic patching. So, you know, being on top of having a good patch management program, looking at the, you know, was this a big vulnerability? It's at least a medium vulnerability, but that coupled with what we could do with that vulnerability turned it into a critical finding, right? And that's what we're after, is that with our penetration testing, we're not just looking at a vulnerability saying, hey, you got this vulnerability and that vulnerability and that vulnerability. We're trying to chain multiple vulnerabilities together to come up with a critical finding. And something that's actionable and meaningful to your organization. Like if I popped a box, actually give me access to anything, like say I got root on a camera, like, you know, what's that going to necessarily give me? Not necessarily anything, but, you know, where it's important, it's not a critical finding, right? It's an important thing to fix on your network. It's not, but it's not going to end in ransomware potentially. So, well, thank you so much for your time today, and I hope we didn't scare you too much.
Thanks, everyone.
Yeah.
So, loved what you said. Agree with it. One thing I've run into, and this is kind of something I've kind of kicked around for a while, is I love the advice to say, okay, you know, we need to teach people about password management.
Yeah.
But where I stumble, and this is where I'm kind of trying to figure out how to move forward, is if I don't teach them about using tools.
Sweet. Thank you. Yeah, thanks, man. Appreciate it. Well, thank you.